All right. Welcome, everybody, to Standing for Truth. My name is Donny Budinsky, and I am your host and moderator for tonight's epic event, the Great Grand Canyon Showdown. Tonight, we dive into one of the most iconic geological battlegrounds on Earth, the Grand Canyon, a monument of stone, sediment, and scientific controversy. The central question: what does the evidence really say? Was the canyon carved rapidly during a global flood or a short time after the flood, as the young Earth creation model argues? Or does it reflect millions of years of deep time, as the standard geological view maintains? Defending the global flood and young Earth perspective, we have Brian Lauer. Defending the deep time interpretation, we have Dr. Deino. Get ready for a clash of worldviews, models, and interpretations, backed by science and sharp reasoning. This is going to be an eye-opening and powerful debate that you don't want to miss. And of course, this debate is brought to you by Standing For Truth Ministries. Let's jump right into it. Gentlemen, I appreciate you guys being willing to enter the debate coliseum to interact with this important topic. And so let's get acquainted, break the ice a little bit before we get into opening statements and the great Grand Canyon debate itself. Brian, let's start with you. Not your first time here, nor is it your first time doing a debate. You're both experienced enough, I think, to give us an engaging debate to remember on the Grand Canyon. So, Brian, tell us, how have you been? And also tell us a little bit about yourself and your ministry. Great to have you.
Oh, thank you so much, Donny, for putting this together. I've been a little bit busy. I do a lot of creation talks, and also there's some. I spent a lot of time on campus, and there was a lot of interest in starting a Turning Point chapter at the community college and also at the state university, and so I've been making myself available for that. But I like to give people all the information so they can make informed decisions, and that typically doesn't happen in our government schools, museums, or media. And so that's what I try to do. And even, there's other things. I'll be traveling down to Iowa into Doc's neck of the woods. So hopefully this will be a lot of fun. Hopefully our paths will cross in the future. And again, thank you, Donny, for putting this together. And thank you, Doc, for stepping up to the microphone. I have a lot of respect for people who do that.
Brian, I appreciate that. You're staying busy. You're going to continue to be busy. So I appreciate the time that you offer, not only for the debate, but the time that you both offer for the time leading up to the debate, which requires a lot of study and prep, of course. And so, okay, Doc, it's great to have you back as well. Not your first time here on the channel. You've been here for formal debates and open mics in the past. And so I appreciate your time. Doc, it's great to have you. Tell us a little bit about yourself and also a little bit about what you do and your YouTube channel.
All right, sounds good. Well, first, thank you, Donny, for hosting this. Brian, thank you for being my interlocutor. For anyone who's not familiar with me, I am Doktor Deino, or Doc for short. Not the one you're thinking of, if you're a fan of Donny's normal content. My handle online is a parody of Kent. Anyway, I like to talk about dinosaurs. I like to talk about science, and I love to teach people. I also love to meet new people and hear their perspectives on different things. So I'm hoping for a good discussion tonight. Hope I can learn some things too. And I look forward to interacting with everyone out there. Thanks for joining us.
Doc, I appreciate that. Thank you so much. As Brian says, I respect anybody who's willing to engage in dialogue, discussion, and debate with people of differing views and different opinions. I think these kinds of discussions are important. It's important that we get out of our echo chambers for these kinds of discussions. So Brian, Doc, I know you both are always very professional. And so I'm sure this is going to be a good, thought-provoking, Doc, as you said, we all want to learn something tonight. And so thought-provoking debate. Gentlemen, for those in the live chat that want to see more from our guest tonight, Brian Lauer and Dr. Deino, we've got links to their YouTube channels here in the live chat. Doki Doki, appreciate that, brother. There's Brian Lauer from Solidify Your Faith, and there's Dr. Deino, who is also simulcasting. So we're live on a couple different channels with a good mix of views and opinions here being represented. So make sure to check out their channels, give them a subscription. And so, okay, let's go over the format for tonight. We got a formal debate here, comprehensive, which is what we need. Hopefully this can act as one of those go-to debates on the topic of the Grand Canyon, the Grand Canyon controversy, to see two good representations from two very different sides of this issue. 15-minute opening statements starting with Brian Lauer, followed by 8-minute rebuttals, 8-minute uninterrupted rebuttals to address each other's points and arguments brought up in the opening statements. Then we jump into everybody's favorite part of these debates, the discussion. Now, what we've done is we're going to give you guys the best of both worlds. And so we got some cross-examination, and we've also got some free-flowing discussion. How we've organized this is as follows. So we got 15 minutes each for strict cross-examination. Then we're going to transition into another 20 minutes of discussion, but this one will be a little more free-flowing and organic, just discussing the topic and points brought up to that point. Then we got 5-minute closing statements / summaries. Good opportunity to land the plane on our respective positions, address anything we feel has been left hanging up to that point, leaving no stone unturned on both sides. Then the fun continues, because then we get to engage you in the audience. We're flexible, depends on how many questions come in. Of course, what we'll do for those that want to guarantee that their questions, challenges, and objections are engaged by our debaters tonight, we'll bump super chats to the top. And let's do our best, of course, as we're sending in questions. Let's be respectful, professional, and cordial to our guests tonight who have been so gracious with their time. And what I think we're going to do is mix it up as well. We're going to take text questions and challenges, but we're also going to open up the mic. So for those that have a question, but they'd actually prefer to directly join the panel and issue that challenge or question to the debaters, we can do that as well. And it could be fun, because maybe in that case, we can have a follow-up question. So you can come in, join open mic style, ask a question, receive your answer, and then have a follow-up question for our guests to engage as well. So what we'll do is, once we get closer to the audience Q&A section, I'll post the StreamYard link for people to join. Okay, gentlemen, I think we're good to go. We've got all the formalities out of the way, and we're ready for opening statements. Brian, you both have your screens ready to go with your slides. So Brian, just let me know when you're ready to go, and we can set your timer for 15 minutes.
Okay.
And I'll start it when you're ready to present.
All right. Well, thank you so much, Donny, and thank you, Doc. Again, this should be a lot of fun, and thank you everybody for joining. And yeah, hit those super chats, and you can share. I don't know if can you see that screen? Is that
yes.
showing?
Yeah, we're showing your whole desktop for a second there. So
Okay,
you're sitting
all
in
right.
an infinite void.
Okay, there we go. So that's good. Okay, well, the key. Oopsie, what did I do there? I stopped sharing. I wanted to hide it. Sorry about that.
That's okay. That's always a good idea to click hide as well, in case it's blocking any slides. So we are doing this live. Again, anybody just joining either in this live show or over at Doc's live show, again, send in those questions, challenges. Perhaps you hear something tonight that Brian says that you disagree with, or perhaps Doc makes an argument that you want to challenge and object to. Send those in the form of questions, or plan on joining in terms of an open mic Q&A, and you can directly present your question or challenge. Brian, I see your screen shared again at the bottom.
Okay.
Feel free to get that ready to go.
All right.
And clicking hide, definitely beneficial. Is your slideshow still?
Yeah, where did that go? We'll have to find. I'll just click on it. All right. Is that it?
There we go. Yes,
Okay.
that's it. Looks
all right.
good.
I'm not touching anything. So we got, all right.
Did you want to click hide on the little bar at the, if you just click hide, it shouldn't stop sharing. You should be.
It did it again.
Oh, I don't know. It's like it's attached or something.
Yeah. So
slideshow.
I'm just not going to do that.
Brian,
Man, I'm
when
not.
you go to share and you click
Yeah.
share screen.
Yeah.
So if you go to window, you can choose to show just your PowerPoint window rather than your entire screen.
Well,
you're sharing your entire screen when you do that.
Okay, so just go to window.
Yeah,
that what
go
you
to
told me?
Window, and you should see your PowerPoint window there.
Let's see. Yeah, I don't. I'll just go to the entire screen. Oh, wait a minute. Yeah, I'll just go to the
As you're
entire.
doing that,
Okay.
I'll answer a question here. Caden, appreciate the question. Are we allowed to send questions across channel? Yes, in my StreamYard, I've got the simulcast, so I got all the comments from both channels, and I can save the StreamYard link, though. When we get to that point, will be posted in the main chat. So if you want to join that way, you'll have to come check out the main chat. Brian, I see your screen shared again.
Okay.
And so
Well, I'm not going to hide it this time.
no problem.
Do I still have 15 minutes, or did I lose that?
No, unfortunately, now you only got 10 minutes left. So just kidding. You get the full 15 minutes, Brian. Well, it's the least we can do for you. So
well, I appreciate everybody's patience. I'm kind of new at this. It's an old dog. All right. Well, let's just dive right into this. Sorry about the delay. And thank you, Doc, again for stepping up. And let's see. The key to Grand Canyon is bulging and cracking 3 times. But in order to cut the Grand Canyon, we got to put some puzzle pieces in place. We got to answer, how do flat layers form without erosion features? They're just laying there like pancakes. And how do flat layers form under slanted layers? That's a tough one. And then how does this 5 to 10 ton quartzite block get lifted up into sedimentary rock? And this is a pothole that's made by flat, fast-flowing waters, but it's on a 2,000-foot cliff 4 miles from the river. And then these are barbed canyons. The red arrows pointing up, that's where the canyons are flowing. But the blue arrow pointing down, that's the Colorado River. That's the barbed canyons. How does that happen? And then if the river carved the canyon, what carved the side canyons? Those are just as deep, but they don't have rivers. And then what about Red Butte? It's 1,000 feet of sediment capped with volcanic rock. How does that get there? Well, to answer all those questions, we need to have a basic understanding of the hydroplate theory, which posits that half of the ocean was inside the Earth at one time. And the water got hotter and hotter, and it wanted to boil, but it couldn't because there wasn't any room to expand, and it became supercritical water, where it's not really water and it's not really steam, but whatever it does, it dissolves things like crazy. And it starts to dissolve the granite above, and it's getting weaker and weaker and hotter and hotter. And Walt Brown says there's probably 372,000 pounds per square inch on that water. And then finally, the crust got weak enough that it cracked. And the water that crack went in 2 directions, went around the whole world, and came back together on itself like the seam on the baseball. This is the fountains of the Great Deep breaking up. And the water just erupted out of there with tremendous force. And then the granite is getting eroded. Those cliffs are eroding. They're falling in there. That's where we get the sediment for the sedimentary rock. And then those cliffs get wider and wider and wider. And pretty soon there's nothing pushing down on the mantle. So the mantle bulges. And then the continents start sliding. It's like if you had a railroad track and you lift it up, the train's going to start rolling. Well, that's what's happening with the continents. You got North America and South America sliding to the west, and Africa and Europe sliding to the east. And then they keep going until they meet some resistance. And then when the water runs out, they buckle up and form the mountains. And you got these huge compression cracks. And that's what you see in Gunnison Canyon. And for scale, those trees on top of the canyon are 15 feet tall. So there's a lot of pressure. I mean, what force could crush that much granite? Well, my proposal is that the plates on one end stopped because it ran out of lubrication, but the plate on the other side kept on going because it still had lubrication. That's what's going to crush this granite. And those are compression cracks, not tension cracks. Something squished it together. And that's important because you see the same thing in the basement rock of Grand Canyon with the Vishnu schist. Okay, and so then you got the layers that are on the plates that are sliding, and then the basement rock buckles up. And when it buckles up, there's still going to be layers on top of the plate, but it's going to be slanted. And then those other layers, they keep going, and they just bevel it off. That's how you get the slanted layers underneath the flat layers. And then one of them, you see that slanted layer, that quartzite, and then up in the sedimentary rock, that's that block. It just that mud flow lifted it up into sediment, and that's where it sits. How does that happen over millions of years? And that's a 5 to 10 ton block. And it went from down there to up there. And there's some credibility to this proposal because the major mountain ranges are pretty parallel to the mid-Atlantic ridge. So there's could be some, but then the mountains. The mountains are a big mass on a small base. So the mountains sink in. Well, if something sinks in, something has to rise up, and that's the plateaus. And they just block fault. You know, the magma is getting squirted out to the sides, and then where there's a weak point, it's just going to push a block all the way up, and one block at a time. That's how the plateaus formed. And some of the magma gets to the top, and it turns into lava, and it gets hard. And then when all the water for the great denudation comes through, it doesn't wash away the lava, but it washes away everything else, and that's red butte. And that's 1,000 feet of Mesozoic sediment, and it's Mesozoic sediment's kind of crumbly, and then it's got volcanic rock on top of it. And I took this picture as we were driving through. You're gonna, if you go from Phoenix to Grand Canyon, you're gonna see it there on the right. And there's something really interesting too. There's another one over by Desert Views Tower. This is called Cedar Mountain, and that's 900 feet tall. And that's that Cedar Mountain is on the base of it is Kaibab limestone, and I'm standing on Kaibab limestone when I take the picture. So there was 900 feet of sediment above me and all over the place too. And that brings us to the Great Denudation, because before you can cut the 800 cubic miles out of Grand Canyon, you got to remove 2,000 cubic miles from all that area. That's the Great Denudation. And before you can do that, you got to remove 130 some thousand cubic miles with the Grand Staircase. And so what we're talking about with the Grand Staircase, what we're focusing on tonight is in the black box. That's from Echo Cliffs to the Grand Canyon. I believe all that sediment was moved with two big lakes. And the stuff that was above that, now some of it's a mile above that, that was, I believe, removed with tsunamis that were going around the earth after the flood. It just sheet eroded all that stuff. And again, we're just focusing on Echo Cliffs, that's sea to the left, to Grand Canyon. We're not worried about the Bryce Canyon or Zion or anything like that. We're just focusing on the left. And there was huge lakes there. And from a satellite, and you can see this from Brian Nichols' videos, you can see the lake beds. They're different colors. And then when you do the topographical stuff, you got two huge lakes there. And that's why all those weird, like arches and canyon lands and petrified forests, they call that the Grand Circle. All those features are because they were in the bottom of Grand Lake or Hopi Lake. And then the stuff, Bryce Canyon and Zion, those are on the sides of the lake. And there may have been more water inside the water with the water saturated sediment than in the lakes themselves. And that's a lot of water, because these were huge lakes. You got Grand Lake, which is twice as big as Michigan Lake, and that's 57 feet above sea level. And then if you go to, and it's in 4 states, Utah, Arizona, Nebraska, or not Nebraska, New Mexico, Colorado, Utah. And if you're in New Mexico, it'd be 350 feet deep at Farmington. If you're in Colorado, it'd be 1,100 feet at Grand Junction. And if you're in Arizona, it's going to be 1,400 feet. That's a big lake. That's a lot of water sitting a mile in the air. That's a lot of potential energy. And that's not the only lake. You got Hopi Lake, which is about the size of Lake Huron. And that's going to be about 1,000 feet deep in most of those areas. Okay. And so what happens? You got these two huge lakes. They're lifted up on the Colorado Plateau, and Grand Lake's being held back by the Vermilion Cliff system. And once it starts going over that, there's no turning back. And so the red circle, it cuts that funnel. You can't unsee it once you see it. But the arrow that I'm pointing at, that's where that pothole is. That pothole was formed when that lake was draining. And if you look on the upper left there, that's 2,000 feet down. So this just happened to be preserved. And so the lake was draining, and it's cutting over the breach there, cutting over the top of the Echo Cliffs and Vermilion Cliffs, and it makes this pothole. And then it keeps cutting down. And that's how you get it so far away. And then it keeps cutting down, and then it hits the hard Kaibab limestone. And then it spreads out and makes this funnel. And this funnel is 12 miles wide and 18 miles long. And just to give you some scale of that, that's Niagara Falls right there, 3/4 of a mile. There's a lot of water going over Niagara Falls, but could you imagine timesing that by 12 or 13 or 14? That's a lot of water doing a lot of damage. And so it cuts down and it hits the hard Kaibab limestone. That's why I think it didn't happen right after the flood, because then everything would be muddy. The Kaibab limestone had to get solid. And also the cliffs, the sides had to be pretty firm. Otherwise, they just slump in if they were just mud. So anyhow, the lake's draining, it's removing 2,000 feet of sediment there, and then there's nothing pushing down on the sediment, so it bulges and cracks. That's the key right there. It bulged, and then it cracked, and then the water goes through the crack. This is Marble Canyon. That's way different than Grand Canyon. And it goes through, and then it undercuts Hopi Lake, which is 250 feet higher. And so then that starts draining through, and now it's sheet eroding everything. And Walt Brown says that Hopi Falls was 13 times higher than Niagara Falls and may have had 100 times the flow. So now you got two lakes just catastrophically draining and sheet eroding everything on top of that Kaibab limestone. And not only does the limestone bulge, but that whole plateau bulges. There's nothing pushing down, so that area all bulges up and it cracks. Bulging and cracking, number 2. And so now the water that was sheet eroding everything now cuts through the crack there and forms Grand Canyon. But also, as it bulged up, the water table starts flowing downhill, which is north to the east there. And then it's bringing the sediment with it, and it's cutting down, making those canyons, the barbed canyons. And then it flows into the crack and goes the other direction. That's very unusual. And then as it's cutting through that crack, it's cutting below the water table. So now the water is gushing in from the sides, and that's how you get the side canyons without the rivers. And you'll notice the canyons are longer to the north than on the south because that raised up higher. That was higher. It had more water to drain. Okay, and so then it's cutting through that crack, and it's taking away all this sediment, 800 cubic miles of sediment, and it gets down to the hard crystalline rock, that Vishnu schist. It should get wider because it's softer sedimentary rock, but it doesn't. This is what should happen, but it doesn't, because not only there's nothing pushing down on the basement rock, so the basement rock cracks. That's how you get the inner gorge, and that's 46 miles long, and it's up to 1,200 feet deep, and that's the inner gorge, and it's right there where the plateau was. Okay, and so the inner gorge formed, and then where'd all the sediment go? That's big. It went out to the Gulf of California, and that whole area on the floodplain. You know, Walt Brown says 100 or 200 miles to the east or west of the Colorado River, south of Lake Mead, you find big rounded boulders. That means that's a powerful flow because it broke off the sharp edges. And it's surrounded by sand, which means it stopped quickly. Otherwise, the sand would have eroded away. You find large rounded boulders have been found a mile away and 100 feet above the river at Bullhead City, which is way down there. And so then if you want to hear, let's see, a pilot of Bill Wells. He was a fighter pilot, and he also flew commercially, and we interviewed him for the Hydroplate Week of Celebration. That's going to be December 1st to the 6th, and going to hydroplate.org to find out about that. But he says when you take off out of San Diego, then you see the floodplain from the Grand Canyon. And you can find out more about the hydroplate theory. We had a conference a couple of years ago that's on YouTube at the Hydroplate Theory. Brian Nickel has a really good one. You could watch The Origin of Grand Canyon. I think that's the best one out there. And you can see it. And then again, we got the Week of Celebration coming up. So to summarize real quickly, bulging and cracking 3 times. You got these 2 huge lakes a mile up there on the Colorado Plateau. It starts draining over. Grand Lake starts draining, and it cuts down, and then it spreads out to make the funnel, and it removes all that dirt. It bulges, and it cracks. Water flows under that crack, undercuts Hopi Lake, and it sheet erodes everything above the Kaibab limestone, and that thing rises up, and then it cracks, and then it all runs. Oh, I don't have it. Okay, and then it cuts out the canyon. It rises up and it cracks, and then it goes through the canyon, and cuts out the canyon, and then the basement rock bulges and cracks. And so that's the Grand Canyon, bulging and cracking 3 times. Thank you very much. Appreciate it. I will stop sharing now.
Brian Lauer, thank you very much for that first opening statement of roughly 15 minutes. To the audience, I appreciate all the energy. I appreciate all the engagement so far. I am all caught up on your questions and your challenges. I also appreciate the fact that they're all largely on topic. So, gentlemen, I think this is going to be a comprehensive debate as we bring in all these questions as well for the Q&A period. That'll help us to further elaborate on the issues at hand. And so, okay, allow me to reset the timer And Doc, I do see your slides down here, so we'll get those up. And whenever you're ready, please let me know. We'll start the timer of 15 minutes, Doc.
Alrighty. Well, yes, first, for anyone just joining us now, thanks for joining us, folks. Hope you enjoy. And thanks for Brian for his introduction. Now I'm going to give mine. For anyone curious, I am going to be coming at this from the perspective of more conventional science when it comes to the Grand Canyon. I think our understanding of how it formed is pretty well supported, and I hope by the end of this, you'll feel the same way. So, Grand Canyon, history and formation. Before we get into that, what exactly are we debating? We're debating how the Grand Canyon came to be. And in order to understand how it came to be, we need to study its geology, first of all, which is how the layers that make up the canyon walls were deposited, and how those layers changed over time. Then we can discuss how the canyon itself came to be, and how the Colorado River came to lie at the center of Grand Canyon. So, pretty important question to ask. What is geology? Well, it's the study of how rocks form and change. And to very much simplify a very complex process, the life of a rock or rock layer follows three general steps. You have deposition, which is how the building blocks of rocks are put in place and become stone. You have alteration, which is how changes in the local environment affects rocks. And then you have erosion, which is how rocks change when they're exposed to the surface. And we're going to go through these three general phases one by one. So to start off, deposition. Rocks can form basically anywhere that sediment or molten material is allowed to collect. This can be in a forest, under the sea, or on a river's floodplain. And the surrounding environment influences what rock will form in a pretty intuitive way. Swamps are going to produce rock that's full of organic material, like coal. Seafloors produce wide, flat sheets because there's nothing that deep to disturb them. And beaches and deserts create wave and ripple marks, like these. Over on the right, you can see a modern beach and preserved ripples from an ancient one. It's also important to note that rocks that form from sediment, aka sedimentary rock, they almost always create nice flat layers, which then can change. Because step 2, alteration. Once rocks form, they can change in many different ways. Stuff like mountain building or other tectonic events can compress layers, which causes them to bend or crack. This can happen at a tiny microscopic scale or a macroscopic scale that creates mountain chains. You can also cook rocks with heat. Intruding magma, so magma that bores through pre-existing rock, can actually cook the sediment around it. And, sometimes you can kind of have both. If you bury a rock deep enough, it gets really hot and really squished, and that could do some funky things to it, like you can see in the Vishnu schist here, which is at the bottom of Grand Canyon. And now, we get to our final part, erosion. Once rocks become exposed at the surface, they're free to break down and erode. They change chemically and physically, and eventually, most rocks break down into sediments that can go on to form new rocks. And on human timescales, we can see very similar processes occurring in any farmer's field. The same processes that form gullies, such as on the right, apply to larger valleys and canyons. Soil's just kind of soft and easier to erode than rock is, so it helps us see these processes at work within a human's lifespan. Any farmer can tell you that gullies grow exponentially over time. So those are the basics of how rocks form and how they change. Geology also focuses on how to... In geology, we study this formation, we study these changes of rocks and see, or in, sorry, we study how rocks form and change, and we can look at different rocks and see how they've changed over time. When teaching students about geology, it's pretty common to show these changes in stuff like this block diagram here. These are usually based on real locations with different rock layers, faults, magma tubes, stuff like that. And by following the basics of geologic processes, we can reconstruct the past of an area. Feel free to pause the stream and give this a try yourself. See if you can figure out when each event or rock layer had to form before the others. There is an order here, and you can piece it together. And if you just want the answer, there it is right there. The rocks on screen can't really form in any other way without contradicting the physical evidence. And, well, knowing our basic geology, how does that apply to the Grand Canyon? Well, just like a block diagram, the Grand Canyon has a history we can decipher. Because, in order for rock layers to deposit, they kind of have to have something to deposit on. Remember, most sedimentary rock layers form in flat sheets. So, using our basic geologic principles, what's the order of events? Well, usually rocks aren't good at staying in the air very long, so it's a good idea to start at the bottom. And at the bottom of the Grand Canyon, we have the Vishnu Schist. Schist is a metamorphic rock that comes from clay, basically. And it's usually deposited flat because it's sedimentary. But the Vishnu Schist, as you can see, is very squiggly and squished, meaning it was deposited and then compressed into schist. After that, we have an intrusion, which is volcanic rock that bores through pre-existing rock. You can usually tell this because it'll have pieces of the older rock within it, and you also get little offshoots, like these little spikes here, which I'm hoping show up for people. Anyway, we get that granite, and then we had an event which eroded the rock away. This is called a nonconformity. There's also a related thing called a disconformity. Both of them just mean stuff was eroded. You can usually tell things were eroded in a place because you have a very definite contact. It's usually uneven, and you'll see bits of the older rock or underlying rock in the bottom of the younger rock. And you see this with rocks that are in the Unkar group down here. So they incorporate parts of the Vishnu Schist and Zoroaster granite, but they're tilted. But these are sedimentary rocks, so they were deposited flat and tilted. Then eroded again. Then new stuff was deposited on, all the way up to the Moab limestone, where it's eroded again, up to the Supai group, eroded again, all the way up to the Kaibab Formation, which is where the modern erosion is. If sediment starts to deposit on top of this layer, it will form another disconformity. And again, geology follows fairly basic logic. Rocks don't sit in the air very long. So if you have layers depositing in an area, they kind of need something to deposit on. You can't get the Hermit Shale if the Supai group isn't here. But for the Grand Canyon, this isn't where our story ends. You might notice this big void over here. So, taking a wider scope at the bigger area that around the Grand Canyon, it sits on a large plateau. Based on geologic evidence, the plateau began to rise pretty well after the uppermost layers of the Grand Canyon were deposited. And recalling our basic geology steps, when rock is uplifted, what happens? It gets eroded. For example, a tall dirt pile is going to erode faster than a short pile. The same is true with plateaus, just takes longer. And when a plateau rises, rivers that sit on it will rise too. Rivers with a high grade or angle between the start and the end will erode faster than ones with a lower grade. And the grade increases if the headwaters rise. If the mouth falls, or if the two get closer together. Now going back here, again, Grand Canyon, it's on the Colorado Plateau. It's been uplifted, so stuff's eroding faster. But what else has changed in this area? Well, if we go out west, we find that the Colorado River comes out in the Gulf of California. And, again, according to geologic evidence, this gulf began to open because of a rift zone that runs between Baja California and mainland Mexico. This happened pretty well before the last ice age. And the formation of this rift and the Gulf dramatically shortened the path of the ancestral Colorado, increasing its grade. And then came the Ice Age. See, when ice sheets cover land, sea levels plummet, lowering river mouths. This causes increased erosion and valleys to form. Sometimes we get massive ones. Think of a fjord in Scandinavia. I should also mention that this ice age was associated with increased precipitation levels all across North America, by the way. So let's put all that together. After the rock layers in the Grand Canyon were deposited, the whole area was uplifted. This, along with rifting to the west, increased the grade of rivers in the area. And then an ice age came, increasing precipitation and further increasing the grade of the Colorado River. So we have more water flowing through a shorter area at a faster rate. What would we expect to happen knowing all of that information? Sounds like a pretty great way to make some pretty grand canyons. And this is something I really want to drive home. The Grand Canyon is big and it is spectacular, but it isn't unique. The entire area is filled with canyons, and we see similar ones all over the globe. We pretty well know how these form. Now, before I'm done, though, there are some things that I want to address. First, there are still mysteries to be solved. As I'm sure Brian will point out, there are still questions about the Grand Canyon's formation. Things we don't know about, such as the exact timing of certain events. But the broad strokes of its formation are not debated in geologic circles for pretty good reason. We know how canyons form. That said, I also want to say I don't know everything. I'm sure there's going to be many great questions tonight. I'll try to answer as many as I can, but I don't know everything, nor do I claim to. If you're interested in learning about geology, I would highly recommend you to reach out to your local university's geo department with questions, especially a geomorphology professor. They will talk your ear off for as long as you care to listen. Oh, and because I know my opponent and Donny's audience, I do want to mention faith really quick. In this discussion, I want to focus on the geology of the Grand Canyon and its formation. I don't want to debate theology. So, I'm just going to go ahead and concede for Brian that the Christian God exists, the Christian God created the universe, and the Christian God may have instigated the formation of Earth and life upon it. Again, I don't want to debate theology. I'm not coming at this from a blind chance perspective. I want to talk rocks. So, that's my opening. I hope you all enjoyed, and thanks for listening.
Doc, thank you very much for that first opening statement of 15 minutes. Gentlemen, I appreciate the work and time that you both put into the construction of those opening statements. Clearly, we have a lot of points and arguments to respond to and interact with in a fast-paced rebuttal. And so rebuttal time is 8 minutes. Before I hand it back to Brian, though, I do want to remind the audience that we will be having an audience Q&A once we're done with the main portion of tonight's debate: opening statements, rebuttals, cross-exam, discussion, and closing statements. So please continue sending in those questions and challenges. And right before the audience Q&A starts, I'll post the StreamYard link for those that would prefer to directly join the show, as long as you're going to be professional and respectful to our guest tonight, of course, to present your questions and have a little back and forth discussion with them. Okay, Brian, whenever you're ready, we have 8 minutes on the clock for a rebuttal, and I'll start the timer on your first word.
Okay. Can I share my screen? Let's see. Can you see that?
Yes.
Okay, good deal. Well, what we've just seen are two interpretations of a fact. Grand Canyon exists, and there's the government conclusion is that it was formed slowly by a little bit of water and a lot of time. And the hydroplate conclusion is no, it formed quickly by lots of water and a little time. And we need to caution everybody because the government conclusion, they try to erase the line between the conclusion and their fact. And this science book, college textbook warns us about that. It says, separate facts from conclusions. A fact is a verifiable piece of information, whereas a conclusion is a judgment based upon the facts. The news media often mix facts with conclusions without indicating which is which. Well, so does the science book, and so does the Grand Canyon webpage. This is what it says. It says the National Park Service. It says the park is dominated by the spectacular Grand Canyon, a twisting 1 mile deep, 277 mile long gorge formed during some 6 million years of geological activity and erosion by the Colorado River. Did you catch that? There's a fact there that's verifiable. It's 1 mile deep and it's 277 miles long. That's a fact. That's verifiable. But then they just put a conclusion in without telling you. It formed during some 6 million years. They don't know that. That's not verifiable. They can assume that, but it's not verifiable. That's a conclusion, not a fact. And you have to watch out for that on all these placards and textbooks and museums. And then the textbook says, or their website says, the story of how Grand Canyon came to be. And then it says the story begins about 2 billion years ago. So you understand, this isn't science. This is a story. And the same thing in this science of this college textbook. The origin of the geosphere is the story of the birth of our planet. The story begins in an immense cloud. Okay, so this is a story. And if you've missed this part of the book, you're going to think you're learning science, and it's not science. You know, the National Academy of Sciences defines science as the use of evidence to construct testable explanations and predictions of natural phenomena, as well as the knowledge generated through this process. So if it's not testable, it's not science. And then the website goes on to say, scientists know that the Colorado River carved Grand Canyon. They don't know that. They didn't see that. There wasn't a scientist there with a tablet and a textbook, you know, a notebook saying, oh, it eroded this much for 6 million years. They don't have that eyewitness account. They believe it. Yeah, they believe it. I know. Yeah, they can think that, but they don't know that. And then it goes on to say that the Kaibab Plateau, a high point through which the river gingerly slices, poses a problem for geologists. And I thank them for pointing this out. What's the problem? Water certainly doesn't flow uphill. That's a problem. And we'll get to that. And then it says, while keeping these few accepted chapters in the Colorado River's history book in mind, they come up with some hypotheses. So there's 4 Colorado River or Grand Canyon hypotheses on the government website. First is the Little Colorado River hypothesis. In order for this theory to work, the ancestral Colorado River would have needed to flow eastward over the Continental Divide. So let's take a look at that. There's Grand Canyon in the box. There's the Continental Divide. And this is a really neat website. I encourage it. You get, wherever you tap, you can see, you get the elevation. It's en-ustopographic-map.com. And right there, I'm tapping on the river as it flows into the Grand Canyon. It flows in at 3,100 feet. And here's the Continental Divide over in New Mexico. That's at 10,000 or 5,700. Yeah, water doesn't flow uphill. It's not going that way. And then, so throw that theory out. And there's the northwest flowing river hypotheses. In order for this to work, the Kaibab Plateau couldn't look quite like it does today. Unfortunately, no sedimentary deposits have been found to support the theory. So to throw that theory out. And then the spillover theory, and I agree with this one. The catastrophic draining of ancient lakes, I agree. But then it says the Colorado River was temporarily dammed behind the Kaibab Plateau. They got the lake in the wrong spot. It's not going to flow through the middle of the plateau. See, in that dark place with the Grand Canyon going through it, that's the Kaibab Plateau. And the water flows in at 3,100 feet and it flows out at 1,200 feet. And it can't flow uphill. And then the top, the north rim is 8,000 feet and the south rim is 7,400 feet. If that's holding back the lake, it should have flown out the bottom. that's 6,400 feet. Or at the top, that's 5,300 feet. And so that it doesn't work. That's not the right place for the lake. It would have gone around the north, not through the middle of it. And then it goes on, and then it's got another theory. It's a collapse of groundwater karst system. It's a very new idea, and it's still being developed, so they don't have evidence for that one either. And if you want to see all the theories and proposals, you can go into page 237 of the PDF that's online at hpt.rsr.org. You got the proposals on the top and the features on the side, on the left. And then red is no, yellow is maybe, and green is yes. It explains it. And if you look on the column way to the left, the hydroplate column, it's green all the way down. All those features matches it perfectly. And the rest of them are red and yellow. And again, all the way down, it's green. And these people should be able to look at all these at the museums and at the Grand Canyon so they can think. Otherwise, they're just memorizing. And if you want to see more problems with the Grand Canyon, with the river covering the canyon, you go into Real Science Radio, rsr.org, and search Grand Canyon Month. And so what we have here is the fact, and we got two different conclusions. Was it slowly or was it quickly? And people should be able to look at them. And that's how I'd like to close with this. We should do what Dr. Thomas Chamberlain said. He warned researchers not to let one hypothesis dominate their thinking. Instead, they should always have or seek multiple working hypotheses. So then they can sharpen their analytical skills and develop thoroughness and reduce biases and think independently. Otherwise, people just memorize and conform. And that's what my goal is, to get people to see multiple theories, not just one. Because if you just agree with the consensus, my goodness, what a train wreck that is. You know, the guy who figured out Ignace Simoes, he figured out you should wash your hands after doing an autopsy, but it went against the consensus, the way he was ridiculed. And so we'll just leave it with that. Again, if there's 4 theories on the Grand Canyon website. I'll stop sharing right now. And to just summarize real quickly, there's 4 theories on the Grand Canyon website. None of them work. I submitted this one for the hydroplate theory, but they haven't put it up. And I encourage more people to start pointing it out to the web, pointing it out to the service. Let's have more than one theory so we can think. I'm done. People should be done memorizing and just swallowing what they spoon feed us. Okay, so thanks so much, and I appreciate your attention.
Brian, thank you very much for that fast-paced rebuttal. You blink and it's over. These rebuttals go by quick. And so, gentlemen, great job so far. I'm really enjoying this. As Doc said at the end of his opening statement, we're here to talk rocks. This is what I like. So, okay, let's transition into Doc, your rebuttal. 8 minutes, whenever you're ready. Please let me know, and we'll start the timer on your first word. Go ahead.
Okie dokie. Well, I don't really have any visuals to share. I do feel like noting, Brian, your rebuttal didn't really feel like a rebuttal. It was more an extension to your intro. I'm hoping I can hear some pushback on some of the points I brought up in my opening. As for yours, I kept notes. So starting from the top, how do you get slanted layers below flat ones? The slanted layers were deposited and then slanted. And that's not just an off-the-cuff inference. The entire area in rocks of similar age is buckled. We have evidence of multiple island continents colliding with North America very, very long time ago, which caused a lot of the layers to bend and buckle and slant. This happened with the Mission schist. It happened with stuff on top of it. And yeah, they tilted, then they were eroded flat, and new stuff was deposited on top of them. You asked a couple times, how do you get inclusions, which are pieces of older rock in newer rock? Well, it's pretty simple. The newer rock is made of older rock. And if the older rock is around on the surface, parts of it are going to erode and get reburied. It happens. You can see this in rivers where you'll see pieces of rock from cliffs upriver in point bars. They just keep getting buried. It happens. How do you get potholes 100 feet above a river? Well, I don't know where exactly that picture was taken, but it looked like a sedimentary rock. A lot of sedimentary rocks are pretty susceptible to erosion, and you get potholes like that all the time. I'm from eastern Iowa originally. That's how you get caves. It happens. How do side canyons form? So canyons along the side of bigger canyons. When you have a canyon forming, you also have water flowing down the sides of that canyon, and some places are going to be more susceptible to erosion. They're side channels, they're gullies. You see them in every valley, everywhere. Again, the Grand Canyon is exceptional in scale, but it isn't unique. It's just a big canyon. You also asked about Red Butte, which is a layer of Mesozoic rock capped with volcanic rock that rises above its surroundings. That volcanic cap is going to be made of much more resilient material than the Mesozoic rock that was surrounding it. So it protects the Mesozoic rock directly under it. That's also how you get hoodoos and arches, actually. In Arches National Park, they're arches of resilient stone on top of weaker stone, and the resilient stone helps protect them. How these form is pretty well understood. You also brought up hydroplate as a major explanation for a lot of things. The reason why we don't accept hydroplate is because the physics that would require it to work can't happen on Earth. People who are better at math than I have done the math on how much friction and heat would be generated as the continents move at the pace you are requiring. Earth would be a ball of plasma. We can't handle the heat that would produce from friction alone. And that's before getting into all the other sources of heat that young Earth in general has an issue with. You also mentioned metamorphic rock that's crushed. That happens. That happens when mountains squish together. That happens when rock is buried really far. You'd have to show the images you showed again, but those look like granite that has other igneous rock veins going through it. That's pretty common, especially in very deep rock. The deeper you go, the more common magma is. You also mentioned major mountain ranges that are parallel to the mid-oceanic ridge. There are some that are parallel to it. There are other possible causes for it, namely the continents moving over oceanic crust on the other side that pushes up mountains. I would like to ask you though, what about mountain ranges that cut across the mid-Atlantic ridge? Because we have those. The Appalachian Mountains continue in the northern UK. It's the same rock layers. We just have a different name because we found, well, the Western world found one mountain range before the other. You asked where sediment goes from erosion. It moves around. Rivers are very good at transporting sediment, and they deposit it wherever they go, at least wherever they're not eroding. In particular, the Colorado River has floodplains going all the way from the last canyon to the ocean. And there are now underwater floodplains that are floodplains and deltas that we can't see at the surface because sea levels were lower during the Ice Age. That was also when a lot of erosion was happening. And then as sea levels rose again, the delta followed back up to its modern position. That's why the modern delta is only a fraction of the sediment that's been transported. Let's see. You asked, how do you get petrified forests? Trees get buried. If you bury a tree fast enough, it doesn't have time to rot, and the cavity can be filled in with things like silica. I believe that's actually chemically what the trees at Petrified Forest National Park are. They're just silica. We know how those form. You asked how arches form. I already explained that. For anyone who wants to actually look up what it's called differential erosion. Different rock layers erode at different rates. And you said Hopi Lake. You think Hopi Lake drained along with another, and that caused the Grand Canyon. We know what it looks like when massive lakes blast through. They cause a massive erosive surface with massive bed forms that don't erode very easily. They don't usually form canyons unless they're plowing through very soft sediment, which these wouldn't be. I also want to touch on, you mentioned the story of how the Grand Canyon formed. That's, humans use metaphors. When a political candidate fights another for the right to be mayor or something, they're not actually fighting. It's just a metaphor. So is a story. There were a lot of other points. I can't really address everything you said in 8 minutes, but I'm looking forward to the discussion because it sounds like you have a lot of good questions. We just need to dig into those a bit. But that's my rebuttal.
Doc, thank you very much for that 8-minute rebuttal. Gentlemen, that concludes our opening statements of 15 minutes and rebuttals of 8 minutes. Again, plenty of points, arguments, and questions on the table to now directly engage in our cross-examination portion of tonight's debate. So what we have here in terms of format is we have each speaker. You both get the opportunity to directly question the other for 15 minutes each before we transition into more of a free-flowing dialogue on the topic. And so feel free to question each other, challenge each other's claims, and clarify key points, especially for the audience sake. Now, since it is strict cross-exam, let's do our best to keep the questions sharp. Obviously, a build-up to the question is okay, but not too much of a build-up. We don't want mini presentations here. We want to keep the answers focused and the exchange respectful, but of course, nothing wrong with a little energy as well. So here we go. Let's have some fun. Doc, you just ended with your rebuttal. So what we'll do is give Brian the first 15 minutes to lead the way in cross-examination, and I'll start the timer on Brian's first point.
Okay, thank you, Doc. The Colorado River flows into Grand Canyon at 3,100 feet and flows out at 1,200 feet. How did it cut a canyon? The rim's 8,000 feet. How does that happen?
Are you referring to the section of the Kaibab Plateau where it kind of bulges up a little bit?
It goes right. It's a mile up there, so it goes right through the Kaibab Plateau instead of going around it. How come that happened?
Well, like you pointed out in your rebuttal section, there are a few different hypotheses. One of the, I think, more well-supported ones is that there was an ancestral Colorado River, or at least rivers in the area, before the Kaibab Plateau started to uplift. And since there was already a river channel there, it was easy for the river to continue flowing and continue eroding as the land around it uplifted.
They didn't have evidence for that ancestral river, though. It had to flow the other way. Okay, if the river carved the canyon, what carved the side canyons? They're just as deep, but they don't have a river.
A lot of that is water running down the sides of the canyon.
But Arizona,
there's also just tributaries.
Arizona is the fourth driest state in the union. Where'd all the water come from?
It is currently. It does still get rain. There are also aquifers that feed into the Grand Canyon that bring water, which comes out through the sides and comes down. And also during the last ice age, there was increased precipitation all over North America, which would have lent the Colorado a lot more water than it has right now.
What caused
I don't know the exact estimates off the top of my head, but they're substantially higher.
What caused the ice age?
What caused the last ice age?
Yeah.
Let's see. I believe most of it is considered to be due to subduction of, It's complicated. A big part of it is CO2 levels steadily dropping throughout the Cenozoic. As CO2 levels get lower, different effects such as Milankovitch cycles, which are patterns in the wobble of Earth's tilt, have a stronger and stronger effect on global climate. Once that happens, you can start getting ice at the poles, and then you can enter into a feedback loop, which is supported by geologic evidence.
So once the Ice Age started, why did it stop?
That's a complicated question. I don't recall off the top of my head what the current accepted hypothesis is for why it fully stopped.
Okay, how did barbed canyons form? Those are the canyons that are forming to they're flowing to in Marble Canyon. They're flowing to the northeast, and yet the Colorado River is flowing to the southwest. How did those form?
Well, I mean, I'll just say that side canyons form in all directions. They can go in the direction of river flow, they can go away from the direction. If you look at the entire Grand Canyon or many other canyons, you'll see barbs like that.
But not flowing the other way. It's flowing the opposite direction as the flow of because I mean, just think this through. You got a table and it's flowing this way, and yet you got a crack that's in the table and it's flowing the other way. That's what they couldn't. Anyhow, do you want to take?
Rivers and streams flow in the path of least resistance. The local resistance can be different than the overall resistance the larger river is affected by.
Okay, how does a little river cut a canyon 10 miles wide?
Well, you got to remember it didn't start out as 10 miles wide. The Grand Canyon would have started out smaller and grew over time. We know this because it's still eroding, it's still growing. As the canyon starts to form, the sides are going to erode more and more and more. You do also get, like I mentioned, increased precipitation during the Ice Age, and just canyons expand. There are canyons larger than the Grand Canyon.
Why aren't there Grand Canyons all over the world if it's just a river cutting through the sediment? Why aren't there Grand Canyons like that everywhere?
There are.
Does the Mississippi have one?
Mississippi does have a rather large river valley, but no, there are larger canyons all over the world.
But shouldn't every river? I mean, the Colorado River is not the mightiest river out there. Shouldn't like the Hudson and the Ganges and the Congo? Shouldn't they all have big canyons like that?
Not every river is the same. The Colorado River goes from a fairly high elevation to a fairly low elevation. It used to have a lot more water flowing through there, and the area has been in a constant state of flux. It's in the perfect place for canyons to form, as evidenced by all the other canyons in the area.
So what eroded the 2,000 cubic miles above the Grand Canyon, the Great Denudation, and left Red Butte and Cedar Mountain? What got rid of all that sediment?
Water, wind, and gravity, the same things that erode most places.
What kind of water? I agree that it was water, but where did your water come from to get rid of all that sediment?
Well, some from the Colorado, but also just other streams and smaller rivers in the area.
But that should cut a valley. It shouldn't sheet erode it all.
That depends on what rock it's interacting with.
The Kaibab limestone.
The Kaibab limestone is apparently more resistant than whatever was right above it, as evidenced by it still being there.
So how did the lava get on top?
Of Red Butte?
Yeah.
I would have to look up that specific lava flow, but generally lava comes from below, and when lava comes up, it forms a dike, which is a vertical lava shaft. Once it reaches the surface, it spreads out over an area. We might not have the dike preserved if all the surrounding material is gone, but in that specific area, it's stuff that would have flowed out from the dike. It's called the sill.
Why are 2 layers of the geologic column missing at the bottom of Grand Canyon? It's actually missing 7 of the 12 layers. The top ones maybe got eroded off, 5 of them. Okay. But the second and third from the bottom are missing. What happened to them?
The Grand Canyon's missing most of the rock layers in the world because it's not all over the world.
Well, this is one of those. Well, but the geologic column, I mean, what's there? No. I mean, do you think the geologic column is accurate?
The geologic column is a concept. It's not a real physical thing.
What was
we
that?
do have rock layers that appear to be of different ages, but not every area is depositing at the same time. There are plenty of areas that are eroding.
So did you say that it's a concept? It's not a real thing? Is that what I thought I heard you say?
The geologic column is a concept, just like a family tree is a concept, yes.
Does it exist in the world? If I dig down right now, am I going to hit a dinosaur layer in Minnesota or in Iowa where you are? Are we going to hit a dinosaur layer?
There are Mesozoic deposits in Iowa, and I believe there are a few in southwest Minnesota.
Right, but would we get all the layers that are in the geologic column if we started digging at your place? Would we get all of them?
No, because different rocks form in different places due to different local conditions.
Right. And my point is,
right.
And my point is those 2 layers account for 72 million years. It's the Ordovician and the Devonian, I believe, and they're missing. And it's like, that's odd, isn't it? And then you got the you got the Schnebly Formation in between the Coconino Sandstone and the Hermit Formation, 270 miles away from Grand Canyon, but it's not there in the Grand Canyon. Why is that?
Because rocks are formed locally, and the conditions that form rock in one place may not be the same for another place.
Okay. All right.
Never mind. It's not my turn to ask questions. But to partially answer your last question, could I share my screen quick, Donny? Thank you. So this is an idealized version of the Grand Canyon. It's not like this for its entire length, but we have known erosive surfaces between different layers. We have erosive contacts. So there may have been rock deposited there from the times you're asking about, but it has since eroded away.
Why aren't there any erosion marks between those layers? They're laying there like pancakes. Wouldn't it rain? You know, when you look at the top of the Grand Canyon, there's erosion up there. There's gullies cut into it. But when you look at the layers of Grand Canyon, there's no gullies. It's just flat. Why is that?
There are erosion marks between some of the layers. Some of them are more gradual transitions.
Well, they're not on that picture. They're not on that picture.
Maybe it's not showing up super well. I'll try to expand it. But there are red lines on the image. Those red lines are disconformities and unconformities. Those are erosive surfaces.
Yeah,
those are places where rock has eroded.
But there should be a valley, you know, like you were talking about rivers cut down. Where's the river? Where's the erosion marks?
We do sometimes find those in contacts between rock layers.
Where did all that
not drawn here on this chart, but they do exist.
Where did all that sediment come from? How come it's so sorted so purely?
What do you mean by purely?
Well, you got the Coconino limestone, you got the sandstone, and it's very distinct. And it's very evenly mixed with cementing agents. So where did the sediment come from to make it? And how did it get so evenly mixed so that there's not hard parts and soft parts, but there was something that mixed it all together? Where did the cementing agent come from to make those layers? And how did they get laid down so flat?
So, okay, there were a couple questions in there. First, I'll just say, on the diagram, for simplicity's sake, they do look fairly uniform. If you actually get up and look at the rocks in person, there are different individual layers, usually due to environmental shifts, environmental changes. Within the Tonto group, there's a mix of fluvial and lake deposits and desert. Like, there are mixes of different rock types within each layer.
Okay, and these layers are not just there in the Grand Canyon. They go all over the continent, and they even find them all over the world. How do you lay down
These
worldwide sediment all at once, like pancake dough?
These specific layers are not found all over the world. A lot of them are found spread throughout the southwest US, but not throughout the entire world.
Like
They're
I
different rocks
believe
of
that,
different age.
yeah, there are worldwide layers, though. How do you lay down worldwide layers of sediment all at once?
The only worldwide layer I can think of is the KT boundary, but even that's not preserved all over the world. We just find scraps of it in rocks of the relevant age.
Well, Tim Clary's done some research on it. He wrote, what's that book? Something in Stone. But he's done the drill things, and yeah, he's found several layers, like the mega sequence, which I don't have it in front of me, but he listed off several of them that are all over the world. And how would you lay down layers of sediment like that all over the world if you don't have a worldwide flood?
I'm not familiar with the research you're describing, but again, a lot of these rock layers are fairly localized to the southwest US. There are some cases where
no, like the Coconino sandstone that goes all over it's pretty much continent wide. I wish I'd have a slide.
I know the Coconino goes as far north as northern Wyoming. I don't know its eastward extent, but none of these are worldwide, and that's true for most rock layers.
Okay. Well, I'm if I can find a slide, if I find the slide, I'll show you, and maybe that, but I don't want to take time on that right now. How did that?
Sure.
How did that?
Or just send me the paper.
Yeah.
For the first round of cross exam, gentlemen, it's going great so far. By the way, I really like the flow. 1 minute left.
How did the funnel form south of Page, Arizona? The funnel between Echo Cliffs and Vermilion Cliffs.
Those form all the time in sedimentary rock layers.
We don't see funnels like that everywhere. 18 miles long, 12 miles wide.
Well, do you have a picture of the funnel, you mean? Because maybe I'm thinking of a different thing.
Yeah, if you want to share. Oh, I can share the screen real quick. Let's see. Hopefully I can find you. Okay, I'll share the screen, and that'll be my last question. The entire screen, and we're going to share that. And here's a picture of it. Right after the question mark, right in the top right, there's that funnel, 18 miles long, 12 miles wide, and then it gets way wide. How does that happen?
It's just an area of erosion.
But I mean, there's
You'll
erosion.
find spots like that all over the western U.S., especially. It's just an area of erosion.
Can you show me another funnel 18 miles long and 12 miles wide?
Yeah, the Mississippi. It has funnels like that feeding into it from all over.
Not between
it's
2,000.
Just an area where a river is down cut through an area.
Those cliffs
spread out and then down cut more.
Those cliffs are 2,000 feet high. Show me a place where there's 2,000-foot cliffs that have a funnel in between them, 18 miles long and 12 miles wide. I don't see them. I don't see them all over.
Sure, they exist. Rivers down cut. They're very good at it, especially if they're funneled into a confined area.
Okay. All right. I will stop sharing, and I think I'm probably out of time then, Donny, huh?
That is 15 minutes basically on the dot. It's like you guys have done this.
Thank you,
before.
Doc.
Very good.
I appreciate that, Doc. Thank you, Donny, and thank you, Doc.
Yeah, that was an excellent first 15 minutes. I appreciate the flow. The questions were quick. The answers were specific. They're on target. And for that reason, you guys moved along smoothly, kept it engaging. So what we're going to do now is reset the timer. And Doc, this time you have 15 minutes to lead the way in cross-examination. I'll start the timer on your first point. Go ahead.
Okay. Let's see. I'm not really sure. Well, I am curious. So Brian, in your rebuttal, you mentioned major mountain ranges that are parallel to the mid-oceanic ridge.
Yeah.
Do you have any thoughts on mountain ranges that appear to cross it?
Well, I don't think they cross it. I think what you're talking about is the area of the Atlantic that slid away. They may have been connected at one time and then they slid apart. And so the mountain range itself does not go across the ocean. And I can show you that also. I could probably, if I let's see, if you want to see it, I can show you that again if you want.
I would have to. I don't remember the exact name of the mountains, but I know in the northern UK there are rocks that are geologically identical to those on the east coast
Oh, sure.
US and the
Yeah.
Appalachians.
Yeah, and
Do
they could
those
have.
mountains predate the continent splitting apart, or
Well, I would say that they could have been a mountain range that was connected, and then the plates slid apart, so they're a lot farther apart. I can let's see if I share this again, so people can see what you're talking about. Oh boy, I'm not the technical wizard like Donny is, as you can see.
I'm not a technical wizard.
Oh man, yeah, you
Learning
are.
more every day, though. That's for
Oh
sure.
man, at least you got.
Technology can be frustrating. I understand.
Oh my goodness, yeah, I'll double that one.
And no
Okay.
worries, Doc. I got your time paused because I do want to make sure that you've got
Yeah.
as much
Yeah.
time as you need to ask questions. Well, Brian, I see it now. You're good.
Yeah. So what you see is that mid-oceanic ridge or that mid-Atlantic ridge, and those are, interestingly enough, those are tension cracks. Those are straight, and that means it's being stretched in two directions. And the mountain range doesn't go all the way across, like you said, and I think we both agree that those mountain ranges could have been connected, and then those continents slid apart. You would propose that they slid away slowly. I would propose that they slid away quickly in one day. And then the mountains rose up in the compression event.
sorry, in one day, you're saying the continents spread that far apart in one day?
Yeah. Because you were saying the hydroplate theory doesn't work because of all the friction. They didn't have friction. They're floating on supercritical water.
Right.
It's like a big air hockey table. And this supercritical water is 50 times slicker than water. And so these things are going. And then you had mentioned that people who have done the math have said that it doesn't work. Well, Walt got his PhD from MIT in mechanical engineering. He understands math. And it was in the heat transfer division. He really understands math. And he's saying that it sounds crazy, but when you look at the evidence, it fits. And then he goes on and he makes accurate predictions. And I think theories that make accurate predictions should not be kicked to the curb. And that's all I'm trying to do tonight, is to bring another idea up for discussion so people can think.
So the problem is the friction doesn't just come from the continent sliding around, though that is a big factor. Rock sliding on top of water, even assuming it can do that, is still going to generate friction. Just water moving generates friction.
Well, this is supercritical water.
Evidence of what's the evidence of this supercritical water existing beneath the continents?
Well, it's coming up today. It's still coming up. They find it in the Atlantic Ocean coming up at 867 miles or 67 degrees. It's coming up in the Gulf of Mexico. Supercritical water does exist, and it's coming up in the bottoms of the ocean.
Are you talking about hydrothermal vents?
Yeah.
We know how a lot of those form. A lot of hydrothermal vents form due to seawater coming in contact with magma that's fairly close to the surface.
Well, what does magma do? It just turns it to steam. Steam's 1200 degrees. This stuff's 800 degrees. It's got to be under pressure so it doesn't turn into steam.
It doesn't just turn into steam. Especially if it's under pressure, it can stay liquid. But the point is, we know where that water is coming from. It comes through the oceanic crust, hits the magma, and then rises back up. We can.
But how does the water get that far down? How does the water get down there to hit it?
through aquifers and through soaking through the sediment.
They find stuff over 5 miles deep. They got those boreholes in Germany and in Russia, and they expected to find, they didn't expect what they were predicting, but they found hot salt water with crushed granite. And water can't get more than 5 miles deep because there's so much pressure, it seals it off as putty. So how do you get water below that?
Water is pretty good at getting low.
Not through putty. I mean, that's why you can't have a cliff. That's why you can't have a cliff 5 miles high on Earth, because it crushes it below. It just kind of turns it to putty.
Okay, then. Let's see. I did have a question. So you brought up how there are competing hypotheses for how the Grand Canyon formed. Is that do you think that's a problem for the standard geologic
No.
model, that there are multiple hypotheses?
No, I think there should be multiple hypotheses. The problem I have is they don't let people see them. They just got the river carved the canyon. That's the only one that they let people see. I think they should say the canyon made the river. That's another one. And so multiple hypotheses is a good thing. The challenge is you just get one dominant hypothesis rammed down everybody's throat at the Grand Canyon with their placards and their websites, and the textbooks. And I think that's a bad thing. I think there should be opposing views, so then kids can think instead of just memorize. It would help them to have critical thinking skills.
Okay, so your hypothesis for how the Grand Canyon formed, do you think that hypothesis holds true for other canyons around the globe?
No.
That they're all massive lakes that came through?
No. The Grand Canyon is very unique. It's a mile. It's a mile high. I would not say that formed all the canyons. I would say no. Some canyons can be because of the earth shifted or cracked or whatever. But I would say that, no, I wouldn't say that proposal fits every canyon.
Alrighty. So I did have a question about just the broader geology of the Grand Canyon. Am I correct in guessing that you think the sediments of the Grand Canyon were formed by Noah's flood?
Yes.
Okay. Do you think that holds true for all of the sediment, from the Vishnu schist all the way up?
Yes.
Okay. So do you think that all of the continental crust came from Noah's flood then? Or is there a boundary? Where is the boundary?
When you say the continental crust, all the continental crust came from? You mean the sediment, the layers of sedimentary rock? Well, I would say the boundary I would say the boundary would be probably the nonconformity, the great conformity, or whatever they call it. I think there could have been basement rock that was created during the creation week, and then the layers on top of that were laid down during Noah's flood. I would suggest that the granite would be the basement rock that was created, and then the sedimentary rock on top of that would be from the flood, most of it. I mean, there's been floods since then, but not to that extent, not where you get so much sorting done.
Okay. Then I guess I would also ask, why do the sedimentary layers above the great unconformity, why are they different in your view? Why do they have what appear to be different environments preserved, different animals from different times?
Well, it could be liquefaction. That's what Walt puts in his book. That's when there's that'd be sorting due to the size, density, and shape. And if you put a bunch of mud, sand, clay in a bottle and shake it up, it's going to settle into its different densities. And with the flood going on, you got the plates that are vibrating up and down as the water's shooting up. It'll slam down and build up pressure, and the water will shoot up. So the plates are vibrating. Plus, you've got these big waves going across because there's no continents to stop the waves. And so the sediment in there is going to be in this constant state of flux, and then it's going to naturally sort out by density, size, and shape. And that's how you get them so flat. I mean, that's how you sorted them. And then there was cementing agents in the water that were mixed together in the subterranean water chambers. And then when the sediments dried out, the cementing agent stuck them together. The sand dunes aren't turning into sandstone. They need a cementing agent. And that's how it got so smooth. It got sorted so pure and got mixed up so well that it turned into stone.
So let's start with density and I guess grain size sorting things.
Yeah.
So from the explanation you just gave, we should have the biggest, densest rock at the bottom and the least dense, smallest grain stuff at the top.
Well,
in the Grand Canyon itself, we have, just going from the top of the Great Unconformity, we have sandstone followed by shale, followed by limestone, followed by mixes of sandstone and shale, and river deposits that include gravel. There is no gradient there.
Well,
they're not sorted by grain size. They're not sorted by density.
Keep in mind, that's a mile. Keep in mind, that's a mile of sediment. And it could have got, there's these few layers could be got laid down and a few more layers, because fast flowing water can lay down sediment quickly too in layers. You can lay them down all at once if it's going like in Mount St. Helens. When that blew up, it laid it laid down a whole bunch of sediment that were laminated. They weren't laid down over millions of years. They were laid down in a pyrostatic flow or whatever they call it. And it got sorted. They were in layers. And then there was this big mud flow that cut a big canyon down. Was it 140 feet deep, 1,000 feet wide? And it cut it in one day. And there's a little Toutle River flowing through it. They call it the mini Grand Canyon of the Toutle River, because it's real similar to Grand Canyon.
So Mount St. Helens, when it erupted, it left a few different depositional types.
Yeah.
Most of them were lahars, which is volcanic sediment mixed with water, lots of water.
Yeah.
We know what a lahar deposit looks like. It doesn't produce anything like you see in the Grand Canyon. As for the mini Grand Canyon that you talked about, that is cut through unconsolidated sediment. It's not analogous to rock.
Right, but if we want to see it cut it, we'd come by and say, see that little river cut that big canyon over millions of years. But we saw it cut it, and we know that didn't happen. And so there's catastrophes that can make these canyons too, and that's what I'm proposing with Grand Canyon. There was a big catastrophe.
So we can, in geology, we acknowledge that catastrophes can happen, but we can recognize them. We would understand that canyon was carved by a lahar deposit.
Well,
it was caused by a lahar. We also know what massive flood deposits look like. They don't carve a canyon like Grand Canyon. It would burrow towards the nearest low point. The Grand Canyon doesn't. It meanders.
Well, it goes straight down with Marble Canyon, then it makes a big right-hand turn. Why did that happen? And why did it flow through that plateau instead of around it? Oh, no, wait, you're asking questions. So I'm sorry. Just disregard that. Say objection, and then Donny can say sustained, and then you can go.
Yeah, objection sustained. But I want to go back to the rock layers in the Grand Canyon.
Okay.
They're not sorted in the way you said they would. And
the way
saying there were multiple depositional events, if there was a global flood, we should see those same depositional events occurring the exact same way all over the globe. But we don't see that.
Sure we do.
Why are they localized?
Well, no, we see worldwide sediment. I'll find that. I'll find those slides if I get some time. But there's worldwide sediments. The Zuni mega sequence, I think he called it, and he showed a map where they're on every continent. There are worldwide layers of sediment. and something in stone. But anyhow, yeah, you go into ICR, Tim Clary, he's got a lot of good research.
Let's see. All right. Well, to be honest, I'm kind of ready to just go into the open discussion. You done?
That's completely fine. You just hit the 13-minute mark. You guys are flowing good. Time is moving along smoothly. You both did a great job asking questions and providing direct answers to those questions. Very helpful for myself and the audience to understand more where you both are coming from. Obviously, two very different perspectives on how the Grand Canyon was formed. To the audience, again, I appreciate the energy and engagement. I'm all caught up on your questions and your challenges, and so feel free to keep those coming in as we continue this discussion. We're now moving into an additional 20 minutes, but gentlemen, this time it's more free-flowing and organic. If you'd like to screen share, present arguments, pick each other's brain on certain points, and challenge each other further on various points, feel free to do so. Doc, you just ended with your roughly 15-minute cross-exam. Therefore, Brian, why don't we allow you to pick the first point or topic that you'd like to discuss?
Oh my. Yeah.
Not to put you on the spot.
Let's go to the Ice Age. What do you think caused the Ice Age? And once it started, why did it stop?
So as I mentioned before, the Ice Age appears to have begun because CO2 levels were gradually falling throughout the Cenozoic. And once you hit a certain point in CO2 levels, Milankovitch cycles take over. Milankovitch cycles are wobbles in the Earth's rotation around its axis, and depending on how they wobble, if CO2 levels are low enough, you can start building ice at the poles during winter. As ice starts to build, you get a higher and higher albedo, or amount of light being reflected back off the Earth, which further lowers temperatures, and you get a feedback loop. It does eventually stabilize, but it feeds back and forth until you get a lot of ice.
And so then why did it
that
stop?
said,
If that started, why would it stop? If you get that feedback loop, why would it stop?
well, without human intervention, it's kind of still going on right now. It's kind of being thrown off at the moment, but the Ice Age, as we call it, an Ice Age is when you have ice at the poles. And while we have had ice at the poles for a long time now, the extent of that ice has been going back and forth. So we get warm periods and cool periods.
Okay,
right now we're in a warm period, and we might be staying in it for a while.
Okay, now that's one perspective of the Ice Age. I would submit another perspective. You know, Ice Age happens when it snows more than it melts year after year after year. And you need warmer oceans to get more precipitation, but you need cooler continents so the snow doesn't melt. And so you had warmer oceans with all the volcanic activity in the Pacific Ocean after that sunk in during the flood. And then you had warmer oceans, but then you had cooler continents because they were higher. And you also had a lot of volcanic activity at that time. So there's more aerosols in the atmosphere, which reflects the sun's heat. So then it snows more than it melts year after year after year. And it's interesting, too, because parts of Alaska and Siberia did not have a glacier during the Ice Age. And that's kind of weird, but it was lower and it was closer to the coast where the water's warmer. Okay, and so then that's how it starts. But how does it stop? Okay, well, during that time, the oceans cool off. So now there's less precipitation, therefore less snow. The continents are sinking in. And also the atmosphere is clearing up. So then the snow is not, there aren't as much snow and more heat's coming through. So now the snow is melting more than it snows. So 400 or 500 years to snow more than it melts, that makes the Ice Age. Then a couple hundred years for it to melt.
So Brian, with how the Ice Age starts, you saying it snows more than it melts?
Yeah.
Yes, I agree. That's what geology says as well.
Yeah.
Like I said, there are alterations in the Milankovitch cycles. And during parts of the cycle, the northern hemisphere especially is exposed to the sun less for longer periods of the year. So you have more time for snow to deposit, less time for snow to melt, and as snow builds up, you get an albedo effect. It's a feedback loop. Over time, the Milankovitch cycles cycle back, and you start getting more melting, and it keeps going back and forth. We have a pretty solid record of sea levels rising and falling, which is often tied to glacial periods over the last 2.5 million years. Right now, we're in a high stage.
How do you know it's 2.5 million years? What's your dating clock?
So for the last ice age, well, we can go for a few different things. We can look at oceanic sediments, to go for raw isotope records, and isotopes as in oxygen and nitrogen, which are pretty good indicators of climate.
But how does that determine time? How does that determine years? The isotopes, why does that? Well, how do you determine, how do you know how old those isotopes are?
Right, sorry, time. So for climate change, we can go with the oceanic records. If you want a year-by-year analysis, we can go with ice cores. There are lots of good ones coming from Antarctica. Less so Greenland because it's more glacially active, but we have a really solid record from Antarctica.
How do you know those are yearly rings and not just warmer, colder rings?
We can do it in a couple different ways. When it comes to seasonal variation, summer ice down in Antarctica is allowed to melt more, and it forms slightly different layers than winter ice, and we see those going consistently. These layers also match up fairly well with carbon-14 for the last 50 or so thousand years. Going farther than that, we have to use other isotopes.
Carbon-14
the trend is still fairly strong.
Carbon-14, you agree with?
Well, carbon dating in general, yeah.
You know, they found carbon.
It's not flawless, but it does work.
They found carbon-14 in dinosaur bones and coal.
Yes.
And oil.
Yes.
And diamonds.
Yes.
How do you explain that?
Yes. In a lot of different ways.
Because carbon-14, if you have it, it can't be more than 100,000 years. So how would diamonds have it?
That's not always true.
Well, the half-life is 5,730 years. So after 10 or so, it's not measurable.
Yes, I'm aware of how radiometric dating works.
Yeah.
When it comes to carbon wow, I cannot talk. When it comes to carbon-14 and dinosaur bones, a lot of that is due to infiltration. Carbon gets into groundwater pretty well, and it can get into bones. It can also get into coal.
How about blood cells?
Get into other things.
How about nerves?
Are you talking about Armitage?
In dinosaur bones. Yeah.
Mark Armitage's work is not good. I'm just going to say that it is not good as a paleontology paper.
Why did they put it on the cover of Microscopy Today then?
Because it's a pretty picture.
Of dinosaur nerves that can't last millions of years.
Of what appear to be degraded nerve and collagen. Of degraded nerves and collagen, yes.
Yeah.
We don't know it's from a dinosaur because he was very awful at keeping track of his site.
Well, then why'd they fire him at California Northridge? He found bone cells. He got it published in Acta Histochemica, and they fired him. Why did they do that?
I don't recall the entire story behind that, but it wasn't to do with his publication. And I know he claims differently, but the university's official reasoning is not to do that.
No, he's right. He sued him for wrongful termination, and he won. So they shouldn't have fired him. But they did.
I don't recall if he won or not.
He did. Yeah, he did win. See, and that's the challenge that we have. We should have competing hypotheses, but they don't allow it.
No, okay. So let me break this down. Mark Armitage's paper is on a horn and a rib that he says are from a Triceratops. The way his publication is written, nobody else can verify that. Because the area he works in has Ice Age deposits and Cretaceous deposits. It could be from a Triceratops, it could be from a bison. And given how the bones look, it seems a lot more likely that it's from a bison. And we have soft tissue from
That's
Ice
not a
Age
bison
remains.
bone. That wasn't a bison bone. It was long. It's like 12 or 18 inches long. That's not a bison bone.
Do you know what a bison latifrons is?
A what?
Do you know what bison latifrons is?
No.
The Ice Age longhorn bison, found all over North America with horns that could reach about 1 meter in length.
Okay.
The horn that he showed, the fragment of the horn that he shows in his paper, because it's not a good picture, it fits bison latifrons. And I know that we can find soft tissue from Ice Age fossils because I've done that in a lab.
Okay, we'll throw his out. But there's 120 other papers that find organic material in dinosaurs. You can go into
Organic material is different from nerve cells or blood cells. And if you're referring to Mary Schweitzer has found fragments of collagen and what might be fragments of blood cells in fossils, but they are microscopic fragments, they're not individual cells. In regards to just organic tissue as an umbrella term, there's a lot of things that are more resilient than cells or even collagen.
Well, Mary Schweitzer said it goes against all our chemical breakdown. It shouldn't be there. She was shocked to find those blood cells.
She said that in the early 2000s. There's been about 2 decades of work since then.
Yeah, and they tried to say it was a biofilm. She couldn't believe her eyes. She had to do the test 17 times, and then she believed it. And then she told her boss, Jack Horner, she said, I got red blood cells. And was he excited that she found something nobody has ever done? He says, can you prove they're not red blood cells? And so then Bob Enyart calls
because that's how science works.
Well, yes.
If you think you have something, you try to disprove any other interpretations.
Okay, so then Bob Enyart calls up Jack and offers him $20,000 to carbon date that bone, along with a bunch of other things. It'd be a blind test, so nobody knows what they're testing, and then come back with the dates and see what we got. And Jack Horner wouldn't do it.
Yeah, because it's pointless.
Why?
I mean, Jack Horner is a lot of things. I'm fairly familiar with him.
Why
but
is it
he doesn't
pointless?
Always do unnecessary things without a good reason.
Why is it pointless? I mean, that's what he told Bob Enyart, and you can listen to it on YouTube on rsr.org. And he said, well, we wouldn't expect to find, carbon-14 in those bones because they're so old. And then Bob says, yeah, I know, but we wouldn't expect to find blood cells in there either.
And they didn't find blood cells. They found fragments of collagen and what might be remnants of blood cells, not cells themselves. Also, when we
even
date
collagen,
a fossil, we don't date the fossil.
What's that? You don't date the fossil?
We don't date the fossil. We date the rock that the fossil is in.
And how do you date the rock?
Usually through radiometric dating. You
can't radiometric date sedimentary rock.
But you can radiometrically date igneous rock that is associated with sedimentary rock and caps it above and below.
Okay, well, there was no cap on this one. It was only 2 or 3 feet below the surface. There was no cap.
It was found in the Hell Creek Formation. Those rock layers are riddled with volcanic layers. It's actually very well understood how old each part of the Hell Creek Formation is.
How do you date the lava?
Well, for a lot of it, it's ash, I believe. But
one
of the most common methods is potassium argon. You can also do strontium or uranium lead.
Yeah, and they got 3 unknowable assumptions in each of them. They don't know the initial condition of the rock. They don't know if there is daughter element in the initial rock. They don't know if the decay process has been constant over billions of years or millions of years. And they don't know if it's been contaminated. And what contaminates it? Water. Water.
We can account for most of those.
How do you account for water?
Especially if we do uranium, lead, and zircons.
How do you code for?
Zircons do not allow lead into their crystalline structure at formation. They always form with just uranium and no daughter lead products. We know
How do you
that
know?
for zircons, and we can test thousands of them at a go. And they all agree on a very narrow gap of time.
Well, yeah, and the rate project too, they also tested the zircons, the helium diffusion rate, and they had a line for billions of years, and they had a line for 6,000 years, and they sent it off to the lab, and it came back as on the 6,000 year line. There's too much helium in there to be billions of years old anyway. It should be gone. And so there's problems with these dating methods. But that's not even my own point. My whole point is there should be multiple theories presented. This is a theory that says it's billions of years, and this is a theory that says it's not. Or just look,
And there have been. We have been fighting over this, like how old the Earth is, how old parts of the Earth are, for hundreds of years. That's not a new thing.
Do you know where the Earth's oldest rock was?
I believe currently they're from Australia, but I could be wrong.
No, it's the moon.
I think they're detrital zircons in Australia.
No, they're teaching. I went through the textbooks, and in our high schools, they teach the kids that the Earth's oldest rock was found in 2008 by Hudson Bay, but NASA came out in 2019 and said that the Earth's oldest rock was on the moon, and this rock formed 12 miles beneath the surface. How are you going to get a rock 12 miles beneath the surface onto the moon? I would suggest the hydroplate theory would answer that one really well.
Do you have a link for that?
Yeah, go into NASA. Yeah. I mean, it's nasa.org, hold this rock. I don't have it handy, but yeah. And I pointed it out to the school board, and they got no problem telling kids false information. I mean, that's just clearly false. And they still teach it.
Oh, okay. Sorry, just looked it up. So the rock you're referring to is dated to about 4.1 billion years old.
Right.
We have older rocks, we at least have older zircons on Earth than that.
Well, that's not what.
However, based on our current understanding of the moon's formation, the moon formed from an impact event with Earth during its formation. A lot of that material was ejected into space from the impact and coalesced into the moon. You can laugh, but...
And how do you know that? How do you know that? I mean, that's one of the things. They got 4 theories out there for the moon. You got the nebula, you got the
there have been a lot of hypotheses.
Well, yeah, and that just tells you that none of them work. And one of the guy, he quipped, he said, the best...
Okay, so you do have a problem with there being multiple hypotheses.
Well, no.
I asked you that earlier.
Well, no, it just means that they don't work. But let people see them.
No, having multiple hypotheses means we have multiple methods that might work, and we test them systematically to see which is best supported. Having multiple hypotheses is good in science because it encourages us to explore.
I agree. It's just not in the textbooks or in the placards at the Grand Canyon or on their website.
You just said having multiple hypotheses was a bad thing, and it means we know nothing.
Well, no. I didn't say it was a bad thing. I said that it doesn't mean that the impact one was right. That's what I'm saying. It's good to have multiple working hypotheses, especially if they make accurate predictions and are validated by NASA discoveries and logically explain 25 major features on Earth and in the solar system, but you don't see them at the Grand Canyon or in the textbooks or in the museums. And that's hurting science a lot. We have to stay in this paradigm that keeps us in this materialistic box. And even Harlan Brent, he said that those scab lands out in Washington was formed by a glacier flood. But the paradigm back then, it was only uniformitarianism. You say, yeah, now they have catastrophes. They allow for it, but they didn't back then. And he was in his 90s.
Science is an evolving field. We learn new things and we incorporate them into our products.
It took him
That's how it works.
Yeah, I know. It took like 60 years for him to, once they got the satellite pictures, they said, oh yeah, that guy was right. Sometimes science progresses one funeral at a time. The people that get their money and their funding and their prestige from a paradigm being right, they don't want to lose that. So they fight all the opposing, the paradigms, the new paradigms, even though theirs can't explain things. And that's where we're at right now. We're on a new paradigm. We are on the verge of a scientific revolution.
Brian, challenging the paradigm is how you make your name in science.
Or get fired.
No, it's how you make your name in science, especially if your evidence is well supported.
Or get fired. Jerry Bergman, I got 3 volumes right there: Slaughter of the Dissidents, Silencing the Darwin Skeptics, Censoring the Darwin Skeptics. It's happened to him 2 or 3 times. There's sacred cows out there.
Bergman also blatantly lies about basic geology and paleontology.
How so? What has he lied about?
He does it in a lot of ways. If you want, I can send you some evidence for that later, but he does.
Well, it's a slanderous statement. Yeah, I'd like to see what you got to back it up.
It's not slander if it's repeatedly demonstrated.
Well, yeah, and you better prove that he's wrong, because he's one of the most prolific writers out there. He's got 2,000 papers, and published, and books, and he does very good research. And yeah, you better be right that he's wrong, because he's got the documents. They don't want to publish his books because of what they say. It kicks a sacred cow. And that's the problem we have in science. You're only allowed one perspective if you want to go up in the ranks. You got the high priests, you got the sacred cows, and they only let the people that agree with them get the degrees.
And Brian, I think saying that demonstrates that you are not familiar with science.
And you are not familiar with the people who've gotten fired because of this. What?
Donny, are we ready for closings?
We are probably really close to the 20 minutes. So yes, I feel like we have left no stone. Look at that. We're at 20 minutes, actually a little bit over. You guys were very thorough in your discussion and in the points that you discussed. I feel like, especially on the Grand Canyon, we did discuss the most relevant points, as we also spent some time on issues like dinosaur soft tissue, collagen, dating methods. So this is good. Time has flown by. Gentlemen, I appreciate you guys giving me a very easy job tonight in terms of moderation. You guys knew exactly, no personal attacks, nothing like that. You guys were on point, on topic, and it was a lot of fun. So to the audience, I am all caught up on your questions. SoCal Preston, appreciate the super chat. Just save that one. Super chats are bumped to the top. We got plenty of other questions and challenges to keep us busy. And then for those that would prefer to ask their question or present their challenge directly in the program itself, we'll post the StreamYard link and you can join as long as you're not coming in for a second debate. We're looking for questions. So points that end in question marks. Gentlemen, very good. 5-minute closing statement. So I think this is important because you guys discussed a lot. A lot of what you discuss is also very technical. Of course, we're digging into the deep things of geology and rocks. And so good opportunity to land the plane, bring everything home on our respective positions, Brian and Doc. And that way we can give the audience the best possible representations of those positions for them to hopefully examine in an objective manner. Gentlemen, here we go. The Grand Canyon controversy, closing statements. I've got your screen up, Brian.
Oh, boy, that's a mess. That's going to hypnotize you. That's what I'm trying to do. All right. Okay. 5 minutes. Okay. Well, just a quick review. The key to Grand Canyon is bulging and cracking 3 times. You've got these 2 huge lakes up on the Colorado Plateau. You got enough water for 3 Grand Lakes. And when Grand Lake overflows, it cuts down until it hits the hard Kaibab limestone. And then it spreads out to make that funnel and erodes 2,000 feet of sediment. And then the Kaibab limestone cracks and the water gushes through that crack and undercuts Hopi Lake. And now you got 2 lakes catastrophically sheet eroding everything. So that's the great denudation that washes everything away but Red Butte and Cedar Mountain. And then now there's nothing pushing down on that area. So then the plateau, the Kaibab Plateau, rises up and it bulges and it cracks. So then the water that was sheet eroding everything gushes through that crack and cuts out the Grand Canyon. And then there's nothing pushing down on the Grand Canyon. So then the basement rock bulges and cracks. And that's how you get the inner gorge. I should have asked more about that. How does that river cut down instead of wide, cut down into the harder rock instead of wide into the softer rock? But that's the Grand Canyon in bulging and cracking 3 times. And so now you can actually think about something. You got the government conclusion where it's a little water and lots of time. You got the hydroplate conclusion where it's lots of water and a little time. And now you can think critically. That's all I want. Just give people another perspective. Let them think. I am so sick and tired of a certain dogma rammed down everybody's throat, and you got to think this way. And so that's what I want. And I think that we should follow what Thomas Chamberlain said. We need multiple working hypotheses so people can think critically instead of just memorize and conform. But the reason that doesn't happen is you can read The Structure of Scientific Revolutions by Thomas Kuhn. It talks about these paradigms that people all agree with, and there's some anomalies. And they may accumulate to the point where normal science becomes difficult and where the weaknesses in the old paradigm are revealed. And that's where we're at right now. Yeah, that Grand Canyon, those theories don't work. This one does. I mean, evolution's falling apart. The Big Bang's falling apart. All in our lifetime, the origin of life is falling apart. That's where we're at. Those paradigms are falling apart. And then when they're unable to account for the anomalies, there's a crisis period. And that's where we're coming to. And you need to have then there's a shift. And you can be early to the party or late to the party, but the party's coming. And I like what Walt Brown says. He says, for a scientific revolution, widespread belief systems seldom change when frequently reinforced by influential institutions such as the universities, media, religious institutions, and the scientific and intellectual elite. That's where we're at. You got people that get their power and prestige and their money from a certain Big Bang evolution, billions of years, millions of years. They don't want to see that go away. But when vast numbers of people realize they've been misled, an intellectual revolution begins. That's what I'm trying to do, get a vast number of people to realize, hey, we've been misled. There's a theory that makes accurate predictions, been validated by NASA discoveries, and logically explains features on Earth and in the solar system. This has been kicked to the curb. We've been misled. Okay, and then you also have to observe. Observers of this revolution should note which side avoids a rational and scientific debate. And so I do commend you, Doc, for stepping up to the microphone. That's kind of rare. And these discussions, thank you, Donny, for doing all this stuff. It is you're doing such a vital service for the cause of science and the theology in those discussions. So thank you so much. And then we got these Hydroplate Week of celebration. I think people would like that, December 1st to the 6th. And with that, I will turn it over and stop sharing. So thanks, Donny. Thanks, Doc. I do appreciate the conversation and the platform so people can see both sides and think instead of just getting the government perspective rammed down their throat.
Well, I enjoy these. I thought this was an excellent debate, gentlemen. Very informative. Clearly, you both have studied this topic extensively, and I love how wide-ranging the topics were, but still all very focused. So Brian, thank you for the 5-minute closing statement. Doc, we got you for a 5-minute closing statement, which means in 5 minutes, we're moving into audience Q&A, and we're looking forward to engaging and interacting with your questions in the audience. So if you have any challenges or questions within the next 5 minutes, send them in. We'll save them and we'll have some fun. Doc, floor is yours. 5 minutes starting now.
All right. Well, I just want to say thanks again, Brian and Donny, for the debate and the platform. I did have fun. Don't think I've really had my mind changed, though, by Brian's hypotheses. Just to be honest, Hydroplate is completely untenable. It's physically impossible in many different individual ways. Kind of wish I'd done better in my my interrogation portion, to be honest, but I'm not really good at doing that sort of thing. I'm better at answering questions most of the time. Otherwise, for the debate itself, I mean, I just have to say, believing in an old Earth isn't a salvation issue, according to many science-affirming Christians, many of whom are in my own field and my personal idols. So I don't really see why it's such a big deal to a lot of people. I just don't. But I don't know. I look forward to the Q&A. Look forward to answering questions, and whatever happens after that, we'll see if we do an after show or not. Ta-da!
Doc, thank you very much for that closing statement. And gentlemen, that concludes opening statements, rebuttals, a cross exam, and a free flowing discussion. Those are oftentimes my favorite debates, where we get a little bit of both, a little bit of formal and informal. And then, of course, closing statements. We're now moving into audience questions. So reminder, you can send in your question in the form of a text question, and you can also join, but I will want to vet those who join. And so it's not required that you have to go on webcam if you have a question. But, oh, Doc, yeah, go ahead.
Sorry, I just remember one last thing I wanted to mention in my closing. If I could do that super quick. I'm sorry.
Yeah, sure. Yeah, you still got time, so go ahead.
To curious people in the audience, reach out to your local universities. Reach out to professors or scientists in geology with your questions. Seriously, please do. I have a bachelor's degree in this subject. I'm not the most informed, and I will be upfront about that. But please feel free to research or to reach out to the experts, to the people who are currently doing research on this stuff. And I do want to emphasize currently there. Don't talk to people who were doing it like 60 years ago who haven't kept up. Talk to the people currently doing geomorphology and geology in general. We're always, well, at least most of us are always excited to get questions and to answer questions and share our research. Like, not just the bulletin at the national parks, like the actual research, and we will talk your head off about it. A lot of us are trying to not let academia be an ivory tower. We want to talk to people and teach people and stuff. Yeah, just reach out to the experts and ask, because there's a lot of good questions out there. Just ask them.
Doc, thank you very much for the additional points in your closing statement. Completely fair, because you still had a few minutes left anyways. And so, okay, I've pinned the link in the live chat. And as I was saying, you can still feel free to send in your text question. We're basically just mixing it up. We're doing a little bit of both. You can call in, or you can send in a text question. And of course, in light of all the questions that we have, we'll never have time to get to all of them. Therefore, super chats, as I see, continue coming in here. SoCal Preston, appreciate it. Just saved it. We'll bump those to the top, and we'll guarantee that those are read. Of course, as long as they're cordial, respectful, and on topic. And so, okay, I've got the StreamYard link pinned. Again, we've done countless. We've done dozens and dozens of hours worth of open mic Q&As and debates and discussions. And occasionally we'll get someone joining who's not necessarily joining for the intended purposes. So to avoid any of those unfortunate circumstances, when you're backstage, you're not required to go on webcam, but just go on webcam backstage for me to see. Give me the thumbs up so I know you're legit. And then that way we can bring you in. Unless I already know who you are, of course, then that's completely fine. Now, remember, questions end in question marks. So again, we're not looking for any additional debates. We're looking for questioners to make their way in, to spend 30 seconds or so making their question, providing the context. We'll allow the guest to answer, and then we'll allow one follow-up to keep it a little more engaging. So, okay, let's start with the questions we have already, though. Doc and Brian, again, very good. This is more of a comment and to fill them free. I appreciate the super chat and support. And Nephilim free. I'm assuming it's directed at you, Doc, and feel free to interact with what he's got to say, but he's pointing to a specific lava flow at the bottom of the Grand Canyon that's been radiometrically dated as 10,000 years old, 117 million years old. So he's basically pointing to an example of some discordant dates here with a range, Doc. Any thoughts on that?
Okay. So the name sounded familiar, so I thought I'd look it up really quick. The Winkaret lava flow it's more accurate to call it a lava field. There's an area in the southwestern US where a lot of lava flows have happened just over the course of history, and at least in our recent geologic past. A lot of them are of different ages, but that's because they're dating individual lava flows. I would have to know which flows in particular he's talking about in order to address that fully. But it's a lava field. There's been multiple flows, so you'd expect multiple ages. Sorry, also, Donny, really quick, my camera is flickering for me. Do you see that, or am I good?
Your screen's flickering or your keyboard?
My camera feed.
Oh, your camera feed. No, you're coming in okay to me. Brian, does Doc look like I don't see any issues on my end.
I don't notice anything here.
So it could just be on your end. Did you want to wait and see if it goes away? Did you want to refresh your system and make your way back in? What do you think would be best, Doc?
It looks like it's gone away.
Okay.
Although I did also remember to Nephilim's question, there are older lava flows in the Grand Canyon. In the diagram I showed in the initial presentation, sorry, going back to the presentation to find the name, because I forgot the name, but yeah, the Zoroaster granite, if you want to call that a lava flow, that's kind of weird, but it did form from a melt, and that's, I believe, dated to a few billion years old. So maybe that's what he's talking about? There's lots of lava flows in the Grand Canyon, just through the layers.
Thank you, Doc. Brian, over to you. Any thoughts? Anything you'd like to add?
Yeah, I thought I'd read somewhere that the RAID team, they dated lava flows and from the bottom and on the top of Grand Canyon, and the ones on the bottom were younger than the ones on the top. And it seemed like that would be a big inconsistency. But the dating methods too, there's a lot of assumptions built into them too.
Thank you, Brian. Doc, did you want a final word there?
Yeah, there are more recent lava flows that have flowed into the Grand Canyon from that lava field, actually. So, yeah, there's going to be some older lava at the top and some younger at the bottom, because lava flows have flowed into the Grand Canyon, and they don't always flow over one another.
Well, the thing that, if I can, they dated the lava dome on Mount St. Helens, and they sent it off, and it came back between 340,000 years and 2.8 million years, and it should have been like 10 years. And it seems like when we know the dates of the rock, when we date them, the method doesn't work. But when we don't know the dates, then we're supposed to assume that it does work. And I think that's not wise.
And that's because it was Steve Austin who did that, right? Yeah, Steve Austin.
Yes.
When Austin did those experiments, not only did he not do them correct, he also sent them to a laboratory that explicitly said it could only date materials that were of at least a few 100,000 years in age.
So how come
he did the wrong preparation methods, and he sent it to a lab that couldn't get the resolution he needed.
So then why did they give him
designed the test to fail?
Then why did they give him dates? Why didn't they say, hey, we can't, this one's too young? Why did they give him a range?
Because that was the smallest amount they could measure.
Well, do you see how there's that's that big of an error? That could be on everything.
That was for that specific lab about 2 decades ago. We have advanced since then.
But it's still based on unknowable assumptions.
No, it's not. He just did it wrong and sent it to the wrong lab for what he was wanting. Other people have gone into it that we don't have the time for here, but the test was designed to fail, and it failed. And creationists have been talking about it ever since.
Doc,
Next question, Donny.
I respectfully disagree.
if I could ask my own question, because I'm the
Yeah.
moderator, I won't push back, but it's such an
Yeah.
interesting point. And Doc, I appreciate your response. What were your thoughts on, because we had Dr. Andrew Snelling say that other geologists in the mainstream world, so other mainstream geochronologists, they use the potassium to argon method for dating young volcanic rocks like Steve Austin did. And he provided many of those examples directly from the mainstream literature, basically as a way to counter what you've said and many of other people have said. So I'm curious as to what your overall thoughts are on other geochronologists basically using the same method and going about dating these young volcanic rocks in the same way that Dr. Steve Austin did.
So, to have a definitive opinion, I would have to see his specific statements on what specific tests he's talking about. But just from what you've said, it would really depend on when those tests were done and at what resolution the labs they sent those samples to were capable of. Because, like I said, we have advanced a lot in the last 20 years. And we went from, I think, needing a few grams of carbon containing material for carbon dating to micrograms now. Like, that much has changed. So yeah, I would have to see exactly when and where these samples were. I would need the context, but off the top of the dome, we have gotten more precise since then.
Okay, well, I appreciate you engaging that question and also the follow-up question. Okay, let's move on to the next one. Very good so far, gentlemen. SoCal Preston, $5 super chat question for Doc. You said science affirming Christians. What does that mean? Are you not aware of that the founders of the major sciences believed Noah's flood?
So by science affirming Christians, I mean Christians who are well informed on the science, what it says, what it means, and what the evidence is based on, and follow that evidence. Like, they understand what the evidence says and what it means. And am I aware that the founders of the major sciences believed in Noah's flood? Yes, most of those people also lived between 1600 and 1800, before geology was a real science, and during its infancy, when Noah's flood was still widely believed as the explanation. With that said, even when geology started getting attention, Noah's flood was immediately put under scrutiny because it just wasn't lining up with a lot of things. But yeah, no, a lot of them believed in Noah's flood because they lived before geology had advanced as a science.
Thank you, Doc. Brian, anything you'd like to add?
Well, I would suggest that science is defined as observable and testable, and a lot of those are not. And again, yeah, the founding fathers, they were creationists. This is 11 Christian men of science, 11 men who changed the world. It's like Maxwell and Faraday and Boyle, and also Walt Brown. Walt Brown's in this book, and he's the one who came up with the hydroplate theory, and he is the Isaac Newton of our day. He has so many accurate predictions, and that's the predictions. That's when you go to your scientists and talk at the college, you can ask them, hey, what predictions have you made? What are your accurate ones? And what ones are you expecting to make? And see how it lines up with the hydroplate. And then also ask them, hey, where did people come from? And then you can find out what they really believe. Do they point you to Adam and Eve, or do they point you to ape-like ancestors? Do they believe what God said, or do they believe what man said? And you need to figure that out right away.
Thank you, Brian. Doc, final word?
Well, I would ask, why is George Washington's Ferrari not in a museum? He lived before it existed, or before the company existed. The same was true of geology. They didn't have a better explanation because of the time they lived in. it's just not a fair question.
Thank you very much. We have a couple guests in the back. One of them here, Josh Musics, good to have you, says that he has a question very similar to this question, and so maybe a good opportunity to bring him in. Somebody else in the backstage named Bill Wells. It says device is not connected, so you'll have to figure that out before we bring you in. And Josh, I'm familiar with you, so I didn't need to vet you. Bill, your name doesn't ring a bell, so if you can, get your devices fixed, go on webcam real quick, give me the thumbs up, we'll bring you in. And also in the private chat, let me know perhaps what your question is, or just give me a little bit of details regarding what you're planning on asking. Okay, Josh, good to have you. Make sure to click unmute and present your question. Go ahead.
Hey, Donny, if the audio's too bad, just kick me to the back. I'll be quick.
Okay, feel free to, it's not the best audio, but it's doable, so feel free to present your question. Good to have you.
Brian, great conversation. If there's an after show, I'll talk to you then. My question is for Doc. So you said that whether or not the flood created the Grand Canyon is not a salvation issue, right? But I think it absolutely is, right? Because if you start picking and choosing which parts of the Bible are metaphorical versus literal, the whole Bible falls apart. So where do you come to the conclusion that it's not a salvation issue? Thank you.
Sure. I say believing in Noah's flood isn't a salvation issue because that's the opinion of many Christian scientists, and most Christians across the world are not young earth creationists, so it doesn't seem to be that big of an issue. It's a problem for some denominations, or at least they feel it is, but most people don't see it as a salvation issue, no.
Thank you, Doc. Yes, most Christians, maybe I'll add this and we'll throw it to Brian, would say that a salvation issue would be believing on the Lord Jesus Christ, the death, burial, and resurrection of Jesus Christ, with one's belief on the age of the earth being secondary and therefore not salvific, perhaps more of an authority issue. But anyways, Brian, anything you'd like to add?
Yeah, I would agree. It's not a salvation issue because you're right. The gospel for Christ died for our sins according to the scriptures, and that he was buried and that he rose again the third day according to the scriptures. That's the gospel. That's what saves us. But it is a consistency. I mean, do we believe the Bible or don't we? You know, if we believe in long ages, you know, if God clearly said for in 6 days the Lord made heaven and earth, the sea and all that in them is. That's Exodus 20:11. That's in the middle of the 10 Commandments. He said he did it in 6 days. And they try and put gaps in there or long ages. But Jesus said in Mark 10:6, but from the beginning of the creation, God made them male and female. That's not millions of years later. That's not billions of years later. That's the beginning, the very beginning of the creation. And then when people say, you know, if Jesus is our example, and he always refers to Genesis as accurate historical events. He refers to the flood as it was in the days of Noah, so shall it be in the days of the coming of the Son of Man. And it was a worldwide destruction, not just a local destruction. And so, yeah, we really have to be careful if we're not following the example of Jesus. You know, he said, if I told you earthly things and you believe not, how shall you believe if I tell you of heavenly things? And if he said it, it's clear. And I don't think if we start doing mental gymnastics to make trying to fit evolution into the Bible, or trying to fit the Big Bang into the Bible, or trying to fit millions of years into the Bible, we're on real thin ice. And that's what I like about the hydroplate theory. It starts with the Bible. It's not catastrophic plate tectonics taking a secular model trying to squeeze it in there, or theistic evolution taking a secular model and trying to squeeze it into the Bible. It's the Bible. It starts with the Bible. And then it goes from there, and then it makes accurate predictions.
Thank you very much, Brian. Doc, final word since the question was for you.
Yeah, just a quick clarifying thing on my point. I believe that salvation is through faith in Jesus Christ alone. But my whole point was to say that it is a salvation issue is because, like I said, if you start picking and choosing which parts are true, oh, it was 6 days, or it represents 6,000 days, or it represents epochs, like, you have to apply the same amount of scrutiny to the gospel. If you can't believe that God did it in 6 days, how can you believe that Christ rose from the dead and actually can pay for your sins? That's my final point, Donny. You could throw me backstage.
Josh, I appreciate it. To be fair, Doc, the question was for you. Therefore, you could have the final word if you'd like it.
Yeah, I'm just going to say, again, most religious leaders and religious people, for that matter, don't see it as a salvation issue. So I'm not going to take the opinion that it is. I'm not here for that kind of conversation.
Thank you very much, Doc. So again, backstage, we've got Bill Wells. I do see that you have a Canyon-related question. So I appreciate you letting me know that in the private chat, but it does still say devices not connected, which means you might just have to plug in your mic or turn on your computer mic and maybe your webcam. I'm not sure. Okay. We've also got Delmy Tree Cutter, who says that he would hold to Brian's position. So Delmy, it's good to have you. Appreciate it. And what was your question? We're trying to keep questions, though, to the audience. We're really trying to keep it on topic, Grand Canyon, and what does the evidence really show? Delmy, good to have you. And who's your question for, and what's your question?
Hey, how you all doing tonight? God bless you all.
God bless.
So my question is for Deino. So Deino, it's kind of a two question, but they're both short.
Uh-oh.
Oh, I think we might have lost. I think we might have lost Delmy. Delmy, just to make sure we're moving along smoothly, I'm going to put you backstage for now, and feel free to rejoin when you fix that issue. And in the meantime, I'll bring in another question. SoCal Preston, appreciate the super chat in question. $5 super chat for both. Can you discuss how geologist J.H. Brett's 1923 was attacked for his theory of the Scablands and the Missoula floods because he supported catastrophism? Brian, did you want to start?
Yeah, that's what happened. The only thing that was allowed was uniformitarianism back then, and he went against it. So he was ridiculed and he was rejected for decades. You know, it wasn't until they got satellite pictures and they thought, oh my goodness, he's right. So when he was in the 90s, he got the award. And it's like everyone he wanted to put, shove it in their face, they were all dead already. And this is one of those examples when science progresses one funeral at a time. And the majority, the consensus is wrong a lot. We shouldn't just follow the consensus.
Thank you, Brian. Doc, over to you.
Well, I am unfortunately not familiar with this particular paper from the 1920s. I would have to read up on it to have an informed opinion. But I will say the consensus is usually a consensus for a reason. If the majority of experts on a topic are swayed by the evidence, that tends to mean something in most scientific fields. Planes don't work too well without wings. And I think most engineers would agree. Sorry, I'm kind of going through his paper right now, too. But yeah, that's my opinion.
Okay, thank you very much, Doc. And okay, here's a question from Sydney Raptor. Sydney Raptor always has good thought-provoking questions, so let's get one of his in here. I appreciate it there, Sydney. Always love the interaction with you. Brian, is Brian's bulging and cracking reason for guiding the Colorado River, was this after the flood? And how did the new still soft flood layers crack?
Yes, it was after the flood. It wasn't right after the flood. It was had to be, I would say, I don't know how long, 100, maybe 200 years later, because the Kaibab limestone had to have time to get solid. And also the sides had to get solid. Otherwise, they just slump in. If this was right after the flood, it would a big slump hole. It would be a big bowl, not a big canyon. And so I would suggest that yeah, it was a while after the flood. And then how did those layers crack? It's because the sediment that was pushing down on it was removed. It's called isostatic rebound. And it's like, yeah, and so then there was nothing pushing down, so the internal force of the earth pushed it up. and then limestone doesn't bend real well, so it cracked, and then the water flows through the crack, and the rest is history.
Thank you very much, Brian. Over to you, Doc.
I mean, I'm just going to say that the bulging and cracking hypothesis seems to rely on hydroplate, and again, it's just not physically possible on Earth. Be a fun world building idea for, I don't know, a D&D planet or something, but it's not physically possible. But I know Brian has another opinion on that.
Brian, you get the last word. It's for you.
Well, Walt Brown does think it's possible, and he's got a PhD from MIT. And when he went to MIT, when he tested, he was in the 99th percentile. He also ran the Benin military lab. He also was taught at the U.S. Air Force Academy. So he's got a lot of credentials behind him. But the main thing is the accurate predictions. You know, what predictions have the consensus guys made? What predictions have the big bangers or the evolutionists or the geologists made? Walt's made some astoundingly accurate predictions, and it's a high time it stopped not being kicked to the curb anymore. And that's the main thing. Currency is accurate predictions are the currency of science. And I submit that they should do the hydroplate protocol. Before you present your theory, you'd give a list of all the accurate predictions that you've made. That could save a lot of time and money.
Comment on that.
Sure, go ahead.
Okay. First, I'm just going to ask Brian, what's a scientific theory?
What's that?
Versus a hypothesis. What's a theory versus a hypothesis?
Well, the theory's got more. It's more robust. It makes accurate. It answers the questions more than the hypothesis is more like a guess, and then they design the test to figure it out. But there's the scientific method that's involved: observable, testable, repeatable. And that's nothing with geology. You're just measuring things and you're looking at things, and that's not testable. So it's not a real, what would you call, hard science. It's got a lot of assumptions to it. And you're right. You know, a lot of the scientists believe it. A lot of the geologists believe with that. Well, yeah, that's if you fire the rest of them. Yeah, a lot of them will believe with that. And then also a lot of them will believe what the funding says. You know, 98% of the scientists believe who's funding, believe what the funders want. And so there's corruption in science, and it's widespread in the medical journals. It's everywhere, and I think we need an awakening, and we need
ignoring the conspiracy theory. I would really encourage you to reach out to geologists, like PhD geologists, and ask them, present them with your ideas,
like Steve
ask
Austin.
them what they think of it.
Like Steve Austin. Would you reach out to Steve Austin to see what he says?
No, because he has demonstrated time and again that he does
that's
not.
What they do. They do ad hominem attacks.
He lies about it.
Yeah, they do ad hominem attacks.
Reach out to your local.
How about Tim Clary? Tim Clary. I mean, I've got the slide.
Reach
if you want
out to non-creationist geologists. You say we're following biased sources. You only seem to follow creationists or non-creationists specifically when they agree with you.
Well, that's the no true Scotsman fallacy right there. Only real scientists, only real scientists believe in evolution.
Reach out to a Christian geologist. There are plenty of them.
Steve Austin, yeah, I've talked
or a Christian paleontologist. There are plenty of them.
I've emailed
that are not Younger's creationists.
I've talked to Tim Clary. Do you want to see somebody? John Baumgartner. I've talked to him. Yeah, they've got solid science on their side. It's just that the secularists won't let it in the door because all they can think about is matter and energy, blind chance. And if anything goes against that, they don't publish it. Look at Richard Sternberg. He put an intelligent design article in the Smithsonian paper or magazine, and he got, they took away his position. There's a witch hunt for creationists. And I'm looking forward to the day when we have the freedom to think. And then after that, I want the freedom to come out of the closet so you can have these views without losing your job.
You have the freedom to think and espouse your views.
Not and keep your job.
You ignore
not and keep your job. You can't.
Then no one's going to take you seriously.
Well, our schools don't even take the errors out of the textbooks. You show it to them, they don't care. Just false information.
So there is a problem with a lot of textbooks being out of date. I think.
Yeah, no. These are
better textbooks.
These are 2020.
I agree with you on that.
These are 2024 textbooks. They were brand new, and they were still full of errors. Brand new.
According to you.
Gentlemen, I enjoy the back and forth. Appreciate the banter. Let's move on to the next one here. We got a good one from Creationist Crybabies coming at you, Brian. Let's see what he's got for you on the Grand Canyon. Gentlemen, the debate has sparked and generated a lot of good discussion in the live chat. That's what we want. We want to generate a good, healthy, scientific discussion on these issues. And so here's the question. If the Grand Canyon were carved in unconsolidated sediments, wouldn't the sides of the canyon show obvious slumping?
Well, not if they turned into sandstone. Like they're sedimentary rock. Sedimentary rock is not going to slump, but there is signs of slumping in the barbed canyons. At the bottom, there are layers that did slump.
Thank you, Brian. Anything you want to add, Doc?
No, not to this, but I did find stuff about Brett's and the Scablands, going back to your previous question. It's okay to go into that after Brian's done with this.
Okay.
Brian, did you want to have a final word here?
No, that's fine.
Okay. And Doc, you were saying there's a point you wanted to bring up?
Yeah, so earlier we talked about the Channel Scablands up in Montana and how Brett's, the geologist who first proposed it, was apparently under attack. He wasn't under attack. His ideas weren't supported by what was known at the time, and the community as a whole was resistant to his ideas because a big flood is a big deal. But later on, findings did support his conclusions, and he seems to be right. That's a scientific process. He had good evidence that something had happened, but we needed more evidence to support it. That's how science works.
That's how science should work.
It's how science does work.
Okay, we got a couple more guests joining us. Let's see here. We got Bill Wells. Bill, good to have you. Your setup is coming in good. And then we've also got SoCal Preston in the house. SoCal has sent in a couple questions and super chat, so I do appreciate the support. Why don't we start with Bill Wells again? Good to have you. And who's your question for, and what is your question? Go ahead, Bill.
My question is for Doc. I was curious how he would explain how these many sink valleys that enter Marble Canyon as well as the side canyons, how those sink valleys were formed, given that there's no evidence of any surface water that would have caused those.
Sink valleys in Marble Canyon. First, let me. I'm not sure what features you're exactly referring
Would those
to.
be the
Sink
barbed
holes?
canyons? Would those be the barbed canyons?
No, sink valleys.
Okay.
I am unfamiliar with that terminology. If we were to bring up a map, would you be able to point me to where that is?
Well, I've seen them. I have a different perspective. I did a lot of flying as my career. Early morning with a low sun angle, you see things that you normally wouldn't see later on in the day. And not only the Grand Canyon, but many parts of the country as well. The Grand Canyon specifically, you will see where you've got long valleys that are empty into the side canyons as well as the crack in Marble Canyon.
I've got a picture of it, Donny. If you want me to share the screen, I've got a picture of it.
Do you have the
Sure,
funnel?
Yeah, no problem.
Okay. Let's see. Yeah, keep on talking, Bill.
Sorry. Can I ask, where did you hear the term sink valley?
It's in Dr. Brown's book.
Walt Brown's book?
Yes.
Okay.
Okay, right here. I don't know if
Yeah, there you go.
Yeah.
You can see the sink valleys going into the crack.
Oh.
And those also empty into the side canyons as well. But there's no evidence of any surface water like a river draining down, especially the ones in the side canyons. So I was just wondering how you'd explain how that ground there clearly subsided as opposed to being carved by some type of surface water.
All right. Well, I will say most of those seem to follow the normal dendritic patterns, like tree-like patterns you see in a lot of just erosional canyons, like side gullies. Those look like they're just side canyons that have carved in pretty deep. At least following the standard geologic model of the area, there's been a lot of uplift. As we've been over, there was lots more precipitation in the area in the past. That would lead to increased rainfall and increased erosion in this area too. So,
but as I
they
fly
just seem to
over
be
it,
normal size side canyons. They're just incised. It happens.
as I fly over it, I see no evidence of any kind of surface water, like a river, that could have carved either the side canyons or formed the sink valleys. Especially the sink valleys, looks like the ground just subsided, that material was removed from underneath it, which the hydroplate theory explains very well. But if all that is solid rock, then how do you get this subsidence?
So you do still get side canyons through solid rock, but I will say this is like a very high desert now. I wouldn't be surprised if you flew over it now and didn't see a lot of water when it wasn't raining. Dry areas like this, when it does rain, it usually flows through very fast and evaporates really fast as well. They would be ephemeral. But I'm sure water does still flow through there when it rains.
But up at the surface, you see no evidence of any river that was flowing into either the side canyons or the sink valleys.
So the kind of tree-like patterns you see in the surface, that is where water flows when there is rain. Like when there's rain, it flows into those patterns and it follows them down into Marble Canyon. That's where the water goes.
But I see no evidence of surface water that formed that.
You don't see it when you fly over
There's
it most of the time because
there's no river extension that's leading into the side canyons, for example. There's no rivers or any streams that are leading into the sink valleys.
Are you saying you don't see where like the water starts and then goes into the canyon?
I see no evidence of where the any type of surface water away from the canyon flowed into the direction of the canyon to carve the sink valleys or the side canyons.
Okay.
It's not there.
So the water that carves those canyons, like what carves those little gullies and canyons there, is mostly rainwater. Some of it might be flowing from the cliffs to either side. Some of it might be coming out as groundwater, but it is going to be ephemeral. There's not always water present there, but it still erodes. You see these kind of things in every desert. They're just streams that dry up.
Okay.
Sorry, maybe I'm not understanding what you're saying, but I'm looking at this and it's just those are normal ephemeral streams that I've seen in many deserts.
With no source.
Do you know what an ephemeral stream is?
You look at the end of those sink valleys. Do you see a river flowing into it or a stream flowing into it? I don't.
You don't see water flowing through it right this second because they're dry right now. When it rains, water comes through. It comes through briefly, it dries fast. Those are just streams that don't always have water in them. You see them in every desert.
Okay.
You see them here in the Midwest, in Iowa, where we get tons of rain. They're just streams that dry up. That's all it is.
I disagree.
Okay.
Brian, was there anything you wanted to add before we move on to?
Yeah, Bill, I was just wondering exactly what are the sink valleys? Is that where my cursor is going right now? I don't know if you can see that.
They run up right into the crack.
Oh, right over in here.
Yeah,
Okay.
and they're a little more pronounced in the side canyons.
Okay.
However, the way that the hydroplate theory explains those opening up is you have the sediments that were freshly laid down during the flood, and several hundred years went by where it took the rock could start to harden up, but the water is still there. The water is still trapped in a mile deep sediments. So when the
Sure.
crack opens up, now that water that is trapped has a place to go, and it's
Okay.
going to start to flow. And
Sure.
it starts to flow, it's going to erode material. And as it starts to erode the material underneath the surface, and since this crack it's bulged up, so the water heading towards the crack is actually flowing uphill. So in the surface, upper layers of the sediments, you wouldn't expect to see water flowing in, but you've
Sure.
got a lot of weight pushing on the farther down you go. And so that water is being squeezed into that crack and it's eroding, forming basically what you could call aquifers. As those aquifers start to flow, they start to erode. The material that is eroding is no longer there to support the surface. So the surface subsides down.
Sure.
It's not eroding as a function of some sort of surface water like a river or stream. It's material that has subsided, and that's what those valleys are, is where the material underneath that surface area has been eroded, and so the valleys sink down because that material that's eroded is no longer there to support.
Okay. Okay. Oh, and just on the next page, this shows the slumped. Somebody had asked about the slumped thing. Oh, and if anybody wants to see these pictures, you go into hpt.rsr.org. You can download the PDF or just click the PDF. And then I just searched sink valleys, and then it went right to that page. And these are free. And somebody asked Walt, so how are you going to, make money on this? He says, I'm not trying to make money. I'm trying to get this idea across. Not that it would make him happier as if it would get accepted, then he could go play golf again. But yeah, this is all right.
Would you be able to share my screen quick?
Yes, to be fair, Doc, let's give you the last word since the question was for you, and then let's move on to the next question. And so here we go. We'll remove that one, and Doc, your screen is shared.
So just out of curiosity, do these look like the kind of valleys you were talking about, Bill?
No.
No, okay. Then I honestly have no idea what you're referring to. I'm sorry.
Okay, well, very good back and forth. Bill Wells, I appreciate you joining us here and offering up a really good question and some good back and forth discussion. Okay, we got SoCal Preston. Preston, another experienced debater. SoCal, appreciate having you here all the way from California. How you doing?
I'm good, brother.
What's your question, brother?
Okay, I'm gonna lead up to my question, but it's for Doc. Doc, hope you're doing well. And my question relates to what I asked about the Missoula floods. And it seems as if you want to just challenge everything a creationist proposes. And the reason why I'm saying that is because when I brought that to your attention, you were not aware of it. And it's a very big event. It's very popular in creationist circles in regards to proving catastrophism. But what you did is you pivoted over somewhere else, quick research, and your research was actually inaccurate. Where did you go to say that it was that he wasn't attacked? Like, what's your research process? I'm just curious because I don't see that you really looked at the other side.
So, to that, I will say it was a question I was unfamiliar with. I was in Super Chat, so I Googled. Sorry, what was his name? Was it Brett's I
Brett's,
googled
yes.
Brett's publication. I glanced over some responses to that, and then a retrospective. And at least according to the retrospective, his ideas were proposed, they were rejected until further evidence was found, and then they were found to be supported.
And so you're a man of science, and you and I are all about being rigorous in our research. And so for me, I was a little taken back at that. I would have slowed down and looked at it more. I want to recommend The Mystery of the Mega Flood. It was done by Nova almost 2 decades ago. 2006 it was released. I watched it and I recorded it on PBS with VHS tape. I was so fascinated. And I was like, wow, I can't believe that this other side is actually doing it. But let me read you something that you can validate yourself. And this is just from straight Wikipedia. You know, there's a source where you can double check it, but it says this: Brett's encountered resistance to his theories from the geology establishment of the day. The geology establishment resistant to such a sweeping theory for the origin of a broad landscape for a variety of reasons, including lack of familiarity with the remote areas of the interior Pacific Northwest, where the research was based, and the lack of status and reputation of Brett's in the eyes of the largely Ivy League-based geology elites. Furthermore, his theory implied the potential possibilities, listen to this, of a biblical flood, which the scientific community strongly rejected. The Geological Society of Washington invited the young Brits to present his previously published research at a meeting on January 12th, 1927, where several other geologists presented competing theories. Brett saw this as an ambush and referred to the group as 6 challenging elders. Their intention was to defeat him in public debate and thereby end the challenge his theories posed to the conservative interpretations of uniformitarianism. I'm almost done, and then I'll leave it to the question. And then he says this at the end is actually, and this is a quote. He says he joked just around the time he died after he got the award, the Penrose Medal. All my enemies are dead, so I have no one to gloat over. So I recommend that you take a look at the video. But my ultimate question is this: is what research have you done on our side? Specifically, what books do you have in your possession that support your interlocutor's case? Or is it that you just Google something really quick and then your answer to me, your follow-up answer was very confident, and you were so confident in that answer, yet I just proved it wrong. So what research books do you have in your possession that support your interlocutor's case?
Okay, so there's a few questions in there. I will say I was very upfront that I was not familiar with this situation when I first heard about it. I glanced over a few things, and I was still hesitant about it because I am not familiar with this situation. I'd never heard of Brett's before or the apparent controversy with his work. But from what you just told me there, people were resistant to his ideas, and apparently he was ambushed at a conference. That unfortunately does happen to people. And since 1923, geology has endeavored to not be like that. We, as a field, we try to be open to ideas, especially when they have sufficient evidence to support them. I can't speak for what people did in the 20s. There was a lot of crummy stuff that happened in the 20s, both in and out of scientific circles. As for what creationist books I have, I admittedly don't own any books that were written by young Earth creationists. I don't really want to own those books, and to be honest, most creationists regurgitate the same few talking points. I'm just going to be honest with that. And there is already an existing body of people who have addressed most of these points. I just kind of do this for fun.
Okay, one last follow-up. And this is why I feel like, and this is what I observe. And I went to university. I went to a secular university. I never took geology, so I never got to challenge any of my geology professors. But I had anthropology and biology. And the usually what I got was, I don't want to, your side doesn't matter to me. I'm not going to research it. I might do a real quick Google search and that's it, but I'm really going to ignore it. And so when I look at Brett's, what I feel like and what I see is that you carry that, and it's not attack on you. Don't get me wrong. It's like you carry that same spirit that his elders carried. And all I'm trying to do is bring some good challenges to you. So here's one more. Are you aware of Hopi Lake? And if not, that question is for Brian too. And that's all I got, Donnie. Hopi Lake and its relationship to the formation of the Grand Canyon. Thank you, Donnie.
So what some creationists call Hopi Lake, at least in conventional science, they appear to be Miocene deposits of, I believe it was a playa. Yeah, it was a playa deposits. But creationists call Hopi Lake. It's not.
What famous scientist? Sorry, I'm not interrupting. But what famous scientist? And Brian, hopefully you know the answer to this. That discovered a comet that was not a biblical creationist, was a supporter of this theory. And that's all I got.
I'm sorry for not memorizing random comet trivia. I don't know.
All right, Brian, do you know the answer?
I'm just gonna guess Halley's Comet. I have no idea.
No, so Hale Bop, when it was either Hale or Bop, supported this. And again, this is all stuff I've learned from PBS Nova, right? You know what PBS is, right? Nova, right? Do you know what Nova is? Doc, do you know what Nova is?
Yes.
Okay, good. All right. So Nova, as you know, is anything but a creationist supported I don't know what you call them, company, corporation, whatever, they're government funded. But the reason I'm bringing this up is because, again, these are arguments that for me, as I don't usually watch Donny's creation debates. I mean, I'm fully supported. I love it. But when this came up, I was like, I got to watch
You're
this.
more of a theology guy, right, David?
Yeah, I'm a theology gangster. You know what I mean? So, but here's the thing is, I love this because this is a thing where Donny, he talks about mitochondria DNA. Like nobody sees that. And I'm like, man, that's some hardcore stuff. But the Grand Canyon, we could see and observe. And so from my standpoint, if you are representing the other side and you don't know anything about, and you're arguing the Grand Canyon, so I'm not talking about random stuff. I'm talking about stuff that's directly related. Don't you think it's important, coming from the scientific field like you are, that you should be aware of Hopi Lake and the formation of a lake that was potentially, that was the name of it, that overflowed and went over the plateau. And one of the scientists that discovered Hale-Bopp was part of that, who's not a biblical creationist, or that Brett, who the Missoula flood was part of in discovering that this only validates, I think, what Brian's talking about, that there's a cover up, that we don't want to talk about it, or people are just not as informed. Do you understand where I'm coming from, at least, Doc?
And let's make that, SoCal, I do appreciate you joining us and engaging. Let's make that the final point in question. We'll throw it back to Doc, and feel free to have the final word, because the question was for you, Doc. Go ahead.
So I'm sorry, there was he disappeared. I'm sorry, there was a lot there. Could you condense that into a sentence or two for your question, please?
When you are talking about the formation of the Grand Canyon, when you don't understand things like Missoula floods, or not aware of the formation of that, which have a history in catastrophism, or Hopi Lake, and the lake that even non-Christians have admitted that is a massive lake that breached the plateau because rivers don't flow uphill. My question is this, is why am I to take you seriously and see you as someone that's truly rigorous in scientific research when you are not even aware of that stuff? That's all. Thanks, Donny. I appreciate it. I'll jump off. Did I answer your question, Doc? Is that clear?
Sure. So I'm aware of the Missoula floods, and yes, it was a catastrophic event. We acknowledge that catastrophic events can happen in geology. They're pretty well understood. They're pretty well established. We understand those. when someone wants to introduce a new catastrophe into the geologic record, that requires a lot of evidence to be supported. When Brett's first put that idea forward, it was not widely supported. It required further research. That's what happens in every field of science.
And it wasn't accepted,
New
right?
ideas
Because
meet
it promoted the
resistance,
flood.
And then it promoted a flood, not Noah's flood. It does not promote Noah's flood. It promotes the flood of glacial Lake Missoula, which was a glacial lake that was held back by an ice dam that burst several times. There were several Missoula floods. In regards to Hopi Lake, what is called Hopi Lake is a Miocene, so nowhere near modern, playa deposit. Playas are lakes that routinely dry up and leave a lot of evaporate deposits. It wasn't a massive lake that burst a dam. It just wasn't, at least according to the geology of the area and geologists that have studied the area. And I'm gonna listen to them. Sorry.
Thank you, gentlemen. Thank you, Donny.
SoCal, is great to have you. Okay, gentlemen, we are coming up at the 3-hour mark. So let's get one more question here. I think the last two were for Doc. So let's get one in for you, Brian, as we start to wind things down. And then Doc can decide if he's going to have an after show after the main debate here. So the conversation might continue in many ways. Tanya Brown, appreciate having you here in the live chat. Thank you for the question. And it's a hydroplate theory specific question, Brian, for you. What makes the water get hotter in the hydroplate theory? And does that exacerbate the supposed heat problem?
That's a good question. I just want to start by saying, Doc, I think you're doing a great job. It's hard to step up to this microphone, especially in this crowd, and I think you're doing great. The water got hotter and hotter. It's a subterranean water chambers. So you got just think of the earth as a big apple. You got the granite around the crust, and then you got the layer of water, and then you got the mantle. And that's his one assumption. And then you got the moon that tugs on the earth. So that's going to cause height. It's going to stretch the crust twice a day. Height, and so that's going to cause heat. And back then the crust wasn't broken into plates like it is today. It was just the crust. So it's going to stretch and compress, stretch and compress, stretch and compress. That heat goes into the water. Water gets hotter and hotter and hotter. It wants to boil, but it can't because there's no room to expand. And then at 705 degrees, then 3,200 pounds per square inch, it becomes supercritical. That's supercritical water, where it's not really water and it's not really steam, but whatever it is, it dissolves things like crazy. So it eventually dissolves. The crust gets weak enough where it shoots out. Okay, so that's where the heat came from. But then the Joule-Thomson effect, that things that expand cool down. So there's going to be a lot of expansion going from 372,000 psi to atmospheric pressure at 14.7. A lot of expanding. So that's going to cool it down a bit there too. And a lot of it's just going to go right through the atmosphere. And so there's, Brian Nickel, he answers those heat problem questions on rsr.org. Just put in rsr.org and search Brian Nickel and heat problems. You'll be able to get, he goes, there's a whole show on it, and he dismantles it a lot. He dismantles it really well.
Thank you, Brian. Doc, floor is yours.
I don't really want to address hydroplate moon. I already have. Physically impossible. Let's move on to the next question.
Can I respond to that?
Yeah, you get the last word, Brian.
Yeah, it's making accurate predictions, Doc. It's got 20-some astoundingly accurate predictions. That should raise your eyebrows. You should take a look at a theory that makes accurate predictions, and not just say that.
I would love to see the list.
Okay. Yeah, it's on page. Yeah, it's on like page 267. If you go into that thing, just type in predictions. You'll see 7. You'll see the whole list of predictions. There's about 58 of them. There's 7 of them that are confirmed in that book. But there's I think it was Fred McNabb. He's found 20 of them. There's 20 astoundingly accurate predictions. And as a scientist, you should want to see them. Don't just kick it to the curb because somebody said it can't happen. Look at the astoundingly accurate predictions, and then The people who say it can't work, ask them, what predictions are you making? What are your accurate predictions?
Thank you, Brian. We'll give you the last word. Question was for you. The Analog Zone has a question for you, Brian. How does hydroplate work if we cannot detect water through seismic waves and whatnot?
How does hydroplate work if we cannot detect water via seismic waves and whatnot?
Is he referring to maybe the water that's under the crust that would have come out at the fountains of the Great Deep? Or, you know, is there evidence? That's kind of the way I'm interpreting it. Maybe I'm interpreting it incorrectly, though.
Well, you know, the seismic waves, there's a lot of things we don't know, but what we do know is it's coming up in the bottom of the Atlantic Ocean. And we do know that it's coming up in the Gulf of Mexico. So we do know that it's there. Whether or not you see it on seismic waves, I mean, that's just another interpretation of stuff. But we do know that it is coming up, or at least that's what the journals are saying. And it's not creation journals. I think it's the New Scientist. New Scientist found, they say, supercritical water never before found in nature coming up in the bottom of the Atlantic Ocean. So that's giving this hydroplate theory some credibility.
Anything you want to add to that, Doc?
I mean, I will say there's a lot of interesting stuff you can do with seismic waves, but no, we don't have any evidence of lots of water existing underneath the continents. There are very hydrated minerals that are found in the lower crust and upper mantle, but no, there's no large water bodies. And
well, that's because the water shot out. That's because a lot of the water shot out. I mean, there's still water down there, but like under, I think they found some under the Himalayas, but a lot of it was propelled out. It's not there anymore.
I'm just going to leave it at it's physically impossible.
Okay. What about this question for you, Doc? Comes from Praise I Am. Appreciate it. What is the foundation of the scientific method? If it's human senses, doesn't that make your epistemology circular?
The scientific method is based in basic logic, and I said at the start of this debate that for the purposes of this debate, God exists, God created the universe, and God likely had a hand in Earth's creation. If that makes my logic circular, then it makes your logic circular too. I don't know what to tell you. I'm not here for that kind of debate.
Thank you, Doc. Anything you want to add to that, Brian?
Yeah, I think you're right. You're saying, well, I reason that it's true, and I reason that my reasoning is true. And so, yeah, there's some, and without an ultimate authority, that you can go round and round in that. But yeah, that's not the topic.
I granted you your ultimate authority.
Yeah, you're right.
For the debate.
Yeah, you're right. Yep. Yeah, that's.
So here's a good one from Creationist Crybaby. Brian, why are fossilized organisms found in association with other fossils from coherent ecosystems, not violently transported and mixed with organisms from dissimilar environments?
I think your assumption in that question is wrong. You find the land animals with the marine animals all the time. You find them all like. You find the fossil graveyards where it's like they were put in a cement mixer and they're all mixed up. It's very rare to find an articulated fossil that's all there in one form. But most of them, most of them there are it's just a fossil graveyard. It's all just mangled up. And my theory on that is maybe they got caught in an eddy, you know, and stuff floats around in an eddy, gets eaten up, goes to the bottom, gets covered in sediment. But yeah, you find they should call it, instead of Dinosaur National Monument, they should call it Clam National Monument. I mean, most of the 99% of the fossils are marine, you know, and there's very few vertebrates, and that screams loudly, I believe, for a worldwide flood. And for a fossil to form, it has to be buried rapidly. Therefore, any layer of rock that has fossils in it was laid down rapidly, not millions of years.
Thank you, Brian. Doc, anything you'd like to add?
Well, I'm just going to say yes, the majority of the fossil record is marine. That's because oceans are really good at creating rock. They just are the bottom of most seaways and oceans. It's very undisturbed. It's great for depositing material. In addition, there's always a steady inflow of plankton from above, which usually helps bury things fairly quickly and preserve them in very fine detail. In regards to articulated skeletons, yeah, they are the exception, but there are still quite a few of them, and quite a few of them in terrestrial deposits as well, especially Dinosaur National Monument. Actually, we have that's part of the Morrison Formation, which I have a lot of personal experience with. We have a really good understanding of the Morrison's geology. Dinosaur National Monument in particular appears to have been a watering hole that dried up. In drying up, it drew in a lot of the larger local land fauna, I should add. There are very few aquatic animals at all. There's like bits of turtles and crocodiles. I don't think there's even any fish at DMNS. And yeah, no, that's true for a lot of rock formations. Morrison, Lance, Hell Creek, Antlers. A lot of them also just have things that can't deposit underwater, like Aeolian sand dunes, which are sand dunes that deposit in a desert. Sand dunes that deposit in a desert form fundamentally differently from sand dunes underwater. Also root systems, intact root systems that we find. That could be a whole debate in of itself. Paleontology is my preferred subject over geology, but geology is fun.
It's a huge field. I'm sure we could have an entire series of debates on these issues. Brian, final word?
Well, you could do an experiment. Those dead deer on the side of the road, are those going to turn into a fossil? No, they're going to get scavenged. They're going to decompose. The only way they form into a fossil is if they're buried rapidly. And there we got things buried all over the world rapidly. I think that screams loudly for a worldwide flood. And again, if you find fossils in a layer of rock, that means that whole layer was laid down rapidly. If it took millions of years, they're going to get scavenged. And then going back to Grand Canyon, they find these nautiloids in the bottom of the Redwall limestone. And some of those nautiloids, they're like shrimp on a snow cone with a shrimp coming out of it. And they find them by the millions, and they're all oriented them a certain direction, and some of them are vertical. So if it took millions of years for that layer to lay down, that thing had to stand on its head for about 20,000 years to get full of sediment. And again, I think that's if that's one theory they want to teach, that's fine, but they should teach another one so people can think.
Thank you, Brian, for that final word. And gentlemen, okay, that was a really good Q&A. We went for over an hour. We had a lot of good discussion there, a lot of good questions, back and forth, good mix of text questions and then open mic Q&A as well. So Brian, Doc, you guys are good sports. I really enjoyed tonight's debate. Very informative, very engaging, and I think it's one of those go-to debates on the Grand Canyon from two different, very different perspectives. And so, okay, let's get some final words, final thoughts, if we could. Brian and Doc, again, I really appreciate your time for the debate, over 3 hours of your time, and also for the time leading up to the debate, which requires, I know, a lot of study and prep. Brian, let's start with you. Appreciate you doing this. Final words?
Yeah, well, I want to thank you for putting this together, and I want to thank Doc for stepping up to the microphone. It's not easy to be in that chair, and I think you did a great job, Doc. The thing that I would encourage you to do is look for theories that make accurate predictions. And if there's Christians that go along with the long ages, well, then they got death before sin, and that's a theological problem. If you got death before sin, why did Jesus have to die on a cross? You know, if it's just figurative. And then you got thorns. Somebody asked, an old earther asked Bob Enyart, well, what do you believe that I don't? And he says, I believe that thistles are thistles are a result of the flood. You know, the thistles came when Adam and Eve sinned. Well, they find thistles in the fossil record before Adam and Eve supposedly got here. So again, when people go talk to those geologists, ask them where people come from. If they don't point you to Adam and Eve, they don't believe what the Bible says. And again, thank you, Doc, for doing what you did, and thank you, Donny, and everybody who stayed to the end. I want to commend you guys for hanging in there. But yeah, it was an enjoyable talk, and I think Doc did a great job.
I agree with you, Brian. Very enjoyable, and I know the audience enjoyed it as well, because the debate itself generated a lot of good discussion and a lot of good questions and challenges, clearly, as we've seen in the Q&A. So for those that want to see more from Brian Lauer from Solidify Your Faith, I do have his channel linked here in the live chat, and then also in the description box of this video. Doc, great to have you as well. I really appreciate your time. And let's hand it to you for some final words and final thoughts.
Well, I'll say again, thank you, Brian. Thank you, Donny, for the debate. Feel like I'm going to be pretty critical on my own performance, but I'll take some time to reflect on that till later. Speaking of later, I will be hosting an after show. I gave Donny the link. I think he put that in the chat. And I guess just general closing thoughts. If you want to talk about sin and death and suffering and all that, you can talk to a theologist about that. I'm here to talk about rocks and fossils and erosion and other things like rivers. I'm not interested in a debate about theology, but for those who do enjoy it, I hope you enjoy it. And yeah, again, reach out to some geologists who are actively publishing in journals. They're more than happy to answer your questions, most of them. And that's where I'll leave it.
Doc, thank you very much. I appreciate those closing thoughts and final words. For those that want to see more from you, firstly, as you said, you're having an after show. I did link that in the live chat. And also here is a channel, or a link to your channel. People can find that in the live chat. Doki Doki, appreciate that, brother. And also in the description box of this video. Okay, gentlemen, that wraps up the Grand Canyon debate controversy. And I'm glad that we could spend so much time engaging the topic of rocks, as Doc said. Obviously, the Grand Canyon is a big issue. It's an interesting reality. And I think you guys both did a good job at presenting your positions and then engaging those positions with criticisms, challenges, and counter arguments. So with that, we are going to wrap things up for tonight. To the audience, I appreciate all of the support, the energy. We had a good mix of views in the chat represented. And thank you to all of those that stepped up to the mic and had questions and challenges for our guests. And also thank you for those who sent in text questions. I had a lot of fun, and I hope you all had as much fun as I did. With that, Standing for Truth is signing off. God bless all.